Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to have a look at one of the very important and an interesting built-in function named as enumerate. So what is enumerate and how is it going to help us in coding with Python? Let's say we have a file comprising of multiple lines and we want to read all the text in it. Along with that, we would also want to segregate those text against the line numbers in which they are present in the file. That's pretty much interesting. We have something called as enumerate to achieve it in a very easier way. So what is this enumerate function all about? Let us start with a very simple example of a list comprising of 3 different elements. Now, if we are feeding these elements present in the list to our enumerate function, what are we going to get? Enumerate function is going to return us list of tuples. This time, the tuples are going to comprise of index of the element as its first element and the element in itself being a second element of the tuple. So that just means enumerate function is going to take an object or an iterable like a list as the input argument to it, and it is going to return us a list comprising of tuples with each tuple having the index of the element and the element in itself. So what is the utility out of it? If we want to get the count of elements that are present in a specific iterable object, it is very much easy to get here. Or if we would want to index each of the elements that are present in the iterable object, again it is pretty much easier. So coming back to our initial use case where we want to use both the index and the value of the iterable, we have enumerate function to do that. Now, if we want to segregate multi-line text in a file by reading each line along with its line number, it's a very simple task. How is it achieved? We will have a for loop having again 2 iterables, one being the index and the second being the text in itself. And we are going to enumerate the file object to get both line number as well as the text present in it. With this, let us jump into our Jupyter notebook to implement enumerate function in Python. Let us create a new Jupyter notebook and name it as enumerate functions. Let us first create a simple list comprising of set of alphabets and execute this cell. We now have a list comprising of alphabets. Now, we would want to see the different items which are present in this above list along with the count of the items. So how can we do it using a for loop? All we could do is we could just print the actual item which is present in the list along with the count of items in the list. To maintain the count, let us create a new variable called count and assign it initially the value of 0. Now, along with the item, we shall also print the count value which is existing at this stage of the program. After every iteration, we are going to increment the count value by 1, stating there is 1 increment in the count, which means there is 1 item that is present in the list. Let's execute this cell and see what's going to happen. We are going to see that A followed by 0, B followed by 1, C followed by 2, D followed by 3. So which is nothing but we have the values from 0 to 3. Simpler way to achieve the same would be with the use of enumerate function. How are we going to use the enumerate function? Let us see here. We have the built-in enumerate function for which we are going to pass the above created list as an argument, and we could see that along with every item we have the corresponding index placed as part of a tuple. That's great. Now let us try to achieve the same example what we tried using the for loop via enumerate function. We will have a for loop. Now we are going to have count as an iterator along with the item also as an iterator in enumerated object. So that means we are going to have the enumerate function which will have the list being passed as an argument to it, and we are going to have the content of the for loop printing the item along with the count of that item. So that just means we are going to get the corresponding index of the item and also the item as part of our print function. Let's execute this cell and see what's going to happen. Now we don't need an explicit counter to keep a count of the items that are present in the list. Instead, the enumerate is going to take that action and simplify our program. If we now want the index or the count value for enumerate function to not start from 0, but with some other value which the end user defines, is it possible to do? Yes, it's very much possible to do in our enumerate function. How do we do it is, let's use the same for loop, count comma item in enumerate function, and in this enumerate function, we are going to have more than one argument this time. So what are those arguments? The first argument will be the same list which we passed above. And the second argument is something that is going to say what is the index value with which our enumerate is going to count. Let's say we are going to give the value as 1. And now we will print the same result what we printed in our previous instruction, which is nothing but count and the item. Let's see what's the result going to be now. If we now see the result, the count starts from 1 or the index starts from 1 with the value assigned to A and 2 for B, C having 3 and D with 4. So that means end user has the flexibility to decide what is the index with which the enumerate should start counting. That's great. With this, we understood what is enumerate function and how do we use it in Python. So up next, we are going to discuss something more interesting with more examples. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to have a discussion regarding another interesting built-in function termed as zip. Yes, you heard it right. We are going to talk and discuss about what is this zip function and how this zip function is going to help us in coding. Let's say we have 3 different lists where the first list is having integers, the second list is comprising of characters, and the third list is comprising of special characters. If we now get a requirement where we would want to convert the above set of lists to below structure, what is this structure? This structure is having one tuple which comprises of first element from each of the above list, another tuple comprising of second element from each of the above list, and finally the third tuple comprising of third element of each of the above lists placed together. Am I right? Yes, that's right. Now, how do we do this in Python? Is there something specifically present in Python to achieve this? Yes, we have zip function to do that. What is this zip function going to do? If we just zip it via our zip function, all it is going to do is it is going to return an iterator of tuples with elements of same position, meaning the first elements from each of these lists will be picked up and are zipped together in the form of a tuple. Similarly, second element from each of these lists are zipped together and placed in the form of a tuple. So is the third element from each of the lists. So what is the zip function that's going to do us here? It is going to return an iterator of tuples with elements of same position from input iterables zipped together. That's great. Let us now quickly jump into our Jupyter notebook to understand and implement zip function in detail. Let us create a new Jupyter notebook and term it as zip function. We will now define 2 lists. The first list being X, which is going to have values as 1, 2, 3, and the second list being Y, which is going to have values as 4, 5, and 6. Let's execute this cell. Now we are going to use the zip function, which will take these 2 elements as its argument and convert this entire result set into a list. We will see what is our result going to be. We are going to see the result as list of tuples. As we discussed earlier in our lecture session, we are now able to get the first elements of both the lists together in a tuple, second elements of both the lists zipped together, and finally the third element of both the lists zipped together. If we now define one list having the values from 0 to 4 and the second list having the values from 0 to 5. So the length of these 2 lists are not same. Now if we try to list the zip result of these 2. So that means if we are now trying to pass list 1 and list 2 as the arguments to the zip function, what is going to happen? We are going to see that the first elements are 0 and 0 in both the cases, which is nothing but the first element of both the lists zipped together. Similarly the second, similarly the third, and similarly the fourth. If we see the result set, we are going to pick up only the 5 elements in both the lists and the 6th element in the second list is neglected. So that means if both the lists are not having the same length, then that doesn't mean we are going to get an error. Instead, the specific indexes of both the lists are taken up and zipped together. Wherever the index does not match, then that value is left out in that specific list. Let us create another list called as list_3, and we are going to have the values in this list as 1, 4, 3, 3 and 7. Let us execute this cell, and now we are going to have a for loop which will have an iterator which is termed as elements in this case, and we are going to have the object here as a zipped result, which is nothing but zip of list underscore 1 and list underscore 3. Now inside this for loop, all we are going to do is we are going to print the elements out of that zipped element result. Now let's execute this cell and see what's going to happen. We are going to see that there are 5 elements that are printed: 0, 1, 1, 4, 2, 3, 3, 3 and 4, 7. Let's say if we now want to find larger of elements for a specific index or for each of the indexes in both the list, then what are we going to do? We are going to simply use the same code which is mentioned above. Then instead of printing just the elements, we are going to print the max of elements for each iteration. So that means we are trying to find the larger of elements for an index in both the lists. Let us execute this cell and see the result. Before that, let us have the delimiter as a simple space. And now let's execute this cell and see what is the result. We are going to see the result as end is an invalid key. The reason being, it should be part of the print, but in this case it is part of the max function. So that is a problem. So we are now going to have it here and then use the same thing with comma being present here. So now end is part of the print function. Let us execute this cell and see. We are going to have the result as 1, 4, 3, 3 and 7. All it did is we found the max value for each iteration or max value out of each tuple which we got, and we printed the result here. That's pretty much easy to find the larger of elements for a specific index in both the lists. Can we simplify the above set of operations further? Yes, that's very much possible. Let us use two concepts that we have learned till now to simplify it further. The first concept being the map function, the second being the same zip function. How do we do it? Before which, let us define this lambda function. What is this lambda function going to do? This lambda function is just going to find the max of the element that's been passed. So how do we define it? We are going to use lambda elements followed by max of elements. That's great. Let us execute this cell and have the lambda function ready. Now all we are going to do is we are going to use the zip function to find the zip of result between list 1 and list 3. We know what is the result set out of this zip function. So when I have list of the zipped result between list 1 and list 3, I'm going to see this value. That's great. Now we are going to use the above lambda function and the above created list. So these two functions will be fed as an argument to our map function to find the largest of the element. Isn't that wow? Yes, that's great. How are we going to do that? We are going to do it by having list function. To this list function, we are going to pass map function as an argument, and to this map function, we are going to have two more arguments. The first argument being the lambda function in itself. What is this lambda function? Lambda of elements colon max of elements. So this is just going to apply max of each element. So where are the elements coming from? Elements are coming from the second argument of the map function. What is the second argument of the map function going to be? It's not going to be the static list. Instead, it is going to be the result of zip of list 1 and list 3. So what is the zip of list 1 and list 3? We knew in the previous instruction that zip of list 1 and list 3 is going to be list of tuples which are going to have the specific indexes zipped together. That's great. So now each of the elements of this list, which are nothing but each tuple present in the list result of the zip function, will be fed as an argument to our lambda function, and we are going to get the max of these two values. So let's execute this cell and see what's the result going to be. We are going to get the result as a list having the max of specific index elements. So that's simply nothing but we were able to find the larger of elements for an index in both the list using a single instruction with the help of map as well as zip function. Just to simplify what exactly happened in the previous instruction, let me give you one simple example or one iteration out of the large instruction. We have this lambda function defined above, which is termed as func. For this func, iteratively the tuples are passed. What are the tuples that were iteratively passed? The first tuple was 0 and 1, and the result of which is 1. That's great. That's been the first element of our output result. In the second iteration, internally, it got 1, 4 as the argument for our func, which gave 4. Similarly, the func took another tuple, which is nothing but 2, 3, where it gave 3 as the result, so on and so forth for the fourth and fifth elements. So hope we got a clear idea of what did our single instruction with map as well as zip function did here to get larger element for an index in both the lists. We will now have a look at another interesting example. Before which, let us go ahead and create two lists. The first list being the names of the employees and the second list being the corresponding profession of those employees. That's great. Let us execute this cell and see what's going to happen. We are now able to create two different lists that are depicting the names separately and their occupation or profession separately. Now, I would want to create a dictionary termed as employees underscore dictionary, and initially it's a empty dictionary. Now, all I want to do is I want to fill this dictionary with key value pairs, key being the name of the employees and the value being their profession. We can achieve it in two ways. The first way being using a for loop. How do we do that? Let me show you that. Before which, let me execute this cell. And now we know that when I'm going to use a zip function, which will be placed inside a list again, and pass both of these names and professions as the arguments for it, what is going to happen? We are going to get list of tuples having the names and the corresponding professions placed together in the tuple. That's great. Now all we need is we want to have a dictionary having the key value pairs, key being the name and the value being profession. The first approach is with the help of for loop, where we are going to have two iterators, one being name, the other one being profession. In what object? In the result of this zipped object. So what are the arguments for this zip? Again, as I said in the previous instruction, it would be names, followed by which the second argument is professions. That's great. Now inside this for loop, what we are going to have is, we are going to use this dictionary which we created above, which is named as employee underscore dict, and have the corresponding name as the key for it with the value being profession. That's great. So we now have the key being the name and the value being the profession. Let's execute this cell and see what's going to happen. Now we will print the details of the dictionary, which is nothing but employees underscore dict. We are going to see that we have the key as names and the value being the professions. Do we have any other simpler and better way to achieve the same without using for loop? Let me show you that. Let us empty up the same dictionary which we created. And now, instead of using a for loop, all we are going to do is we will use the same employees underscore dict. We are going to use this dict function, to which we are going to pass zip of names and profession. That's it. After doing this, let us execute this cell and let's see what's going to happen with this dictionary. We are going to have the same result set what we achieved out of the for loop. With these details on the behavior of zip function and its utility with other built-in functions and various capability of converting from one data structure to another data structure, let us wind up our current lecture. Up next, we are going to get into another very interesting built-in function. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I'm going to take you through very interesting functions and useful utilities in Python programming. So what are they? Before we get into the details of each of them, let me take you through some interesting samples here. What are those samples? They are our favorite cartoon characters. We have a Jerry here having cheese in its hand. Okay. We have Tom, naughty Tom, trying to fight with Jerry. And we have Minion trying to speak something. And finally, we have our favorite Mickey Mouse. Let us see what they are trying to tell us now. Jerry is trying to say that it does not like cheese. Can you believe it? Tom is trying to say that it never fights with Jerry. And Minion is trying to say they are calling apple as Bapple. And finally, Mickey Mouse says that its name is Donald Duck. We shall now evaluate each of the statements said by the cartoon characters into expressions and see whether they are going to yield true or false. Okay, to start with, Jerry says it does not like cheese. But we all know that it likes cheese a lot. It even has one in hand. So that means it is evaluated to false. Okay, the next one is the Tommy, which is a naughty one that tries to say that it never fights with Jerry. But we know that it is fighting with Jerry. So that means it's again evaluated to false. And Minion saying that they call apple as Bapple. Yes, that's true. They don't use pure English to talk. So that means this evaluated to true. Finally, we all know that it's our favorite Mickey Mouse and not Donald Duck. So this expression is also evaluated to false. Let us place all of these evaluated expressions result in a list and assign this entire list to a variable called evaluated_list. Now what we are going to do is, we are going to pass this entire list to a function called as any. So this list is passed as an argument to the any function. Now what is this any function going to return? It is going to return us a boolean value, and that boolean value this time is true for this list. Why is it so? It's purely because we have at least one value which is evaluated to true, or one expression that is evaluated to true in our list which is passed as an argument to the any function. So that's the reason we have the return value as true as part of our any function. Let us now get back to our original example where we had different cartoon characters and the expressions with them evaluated to either true or false. Now, let's say Minion says that they speak pure English. We know that they are not going to speak pure English. Instead, they have their own language. So that means this expression gets evaluated to false again. Okay, we shall again construct a new list out of the evaluated expression. Again, we are going to assign it to a variable called evaluated list and pass it as an argument to our any function. What is it going to do this time? It is going to return us false. That's because all the values that are passed to the any function are false. Which means if entire value set present in the list passed to the any function is false, it returns us the false value. So we now have two cases with which we can work with any function. The first case being having all the elements of the list as false, passing it to any function as an argument, evaluates and provides us the return result as false. The pure reason or the sole reason for this is all the elements present in the input argument are false. Similarly, we have another case where we have at least one value is true, and this is passed as an argument to our any function. This time it returns us the value true. That's because we have at least one expression that is evaluated to true in our entire list passed as an argument to our any function. Let us create a new Jupyter notebook to understand what is any function and how do they behave in Python. Let us create a simple list called as list_1 and have the values in itself as true, true, false, and true. What is this going to do when it is passed as an argument to our any function? If we are going to pass this as an argument to our any function, we are going to see the return result to be as true. Let us consider another example where we are going to pass a list to the function, which is any function, where all the elements inside the list are false in nature. Now let's execute the cell and see what is the result going to be. We are going to see that the result is false. Now we will take another example where the list that is passed to any function has its element as numbers. We will now have 1, 2, 3 and 4. Let's execute this cell and see what's going to happen. We are going to get the result as true because the positive numbers are evaluated to true in this case. Similarly, we are going to consider another list comprising of negative numbers and pass that as an argument to any function. Here as well we are going to see the result as true because whether the number is positive or negative, it is considered as true in Python, and that's the reason we have any function evaluating and getting the result as true for us. We will now see another example where we are going to pass a list to any function which is comprising of only zeros. Now let's see what's going to happen. We are going to get the result as false because each of the zeros are evaluated to false in case of Python. We will now consider any function having a list, and each element in this list will be an expression, meaning we will have a condition stating 3 greater than 2 and 2 less than 5 and 5 greater than 6, and our final expression 7 equal to 8. Let's execute this cell and see what's going to happen. We are going to get the result as true because at least one of these expressions evaluated to true in this case. With this knowledge on any function, let us go back to our lectures and understand what is another function termed as all in case of Python. We shall now take up the same example of Jerry having the cheese, Tom fighting with Jerry, Minion trying to speak something, and finally Mickey Mouse. This time, Jerry says that it likes cheese, and Tom also convicts that it fights with Jerry, and Minion says that they call apple as Bapple, and finally our Mickey Mouse says its name as Mickey Mouse. And now let's evaluate this expression. Again, this is true because Jerry likes cheese. Tom fights with Jerry, that's why it's evaluated to true again. Minions call apple as Bapple. So that's the reason this expression is also evaluated to true. And finally, our favorite Mickey Mouse calls itself as Mickey Mouse. Now let's pick up all these evaluated results and place it inside a list and term it as evaluated list. Now again, we will pass this list as an argument to a different function this time, which is termed as all. So we are going to pass this entire list as an argument to our all function, and this all function is going to return us true. The reason for it is all the elements that are placed in the list which is passed as an argument to our all function is comprising of true values. That's great. Let us now take up the same example which we saw earlier, and this time we are going to say that cheese is not something that Jerry likes. This is not a true expression, so it's evaluated to false. And now we are going to put all these evaluated values back into our list and pass this list as an argument again to our all function. This time, can you guess what the result is? The result is false. That's because at least one element that is part of the list passed as an argument to our all function is evaluated to false. So here as well we have two cases. The first case being at least one element in the list passed as an argument to our all function comprises of false value. Now when at least one value present in the element list passed as an argument to our function is false, it definitely returns false. Similarly, when all the elements that are part of the list passed as an argument to our all function is true, then all will simply evaluate to true and give the result. With this we have two different behaviors that are shown in all function as well. Let us now jump into our Jupyter notebook to implement all function and see how does it behave. Let us create a new Jupyter notebook and name it as all function. Now we are going to use this all function and pass a list as an argument to it, and this list will for the first time comprise of values which are nothing but true. Now if we see the result, the all function returns us true value. Now we are going to use the same all function and have a list comprising of true as well as false as the value in it. We are now going to get the result as false. These two are the expected behavior. Similarly, we are going to use all function again, and we are going to pass the set of numbers here 1, 2, 3, and we are going to see the result as true because each of these numbers are evaluated to true as we said in our previous case. Similarly, if I have positive as well as negative numbers, we are still going to get the result as true. But if we have at least one 0 in the list, then we are going to get the result as false because 0 is always evaluated to false. These things are something which we already knew and implemented for all function. Let me show you another interesting thing. If I have empty list passed as an argument to all function, what are we going to see the result as? We are going to see the result as true. But if we are trying to use empty list in case of any function, trust me, it is going to give us false as the result, which is different when compared to all function. With this, we had great understanding of what is any function, how does it behave, what is all function, how does it behave, and what are the difference between all and any function. That's great. With this, let us wind up our current lecture, and up next we are going to speak about something more interesting and more easier to implement via Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through some more details and variations in the data structures that we learned in Python. Yes, I am going to take you through something called as collections in Python. Before which, let me have a quick recap of one of the data structures that we already learned, which is nothing but dictionary. How do we instantiate a dictionary in Python? One of the ways to do that is we use a keyword called dict, which helps us in instantiating a dictionary object. Yes, that's right. And we know that a dictionary comprises of key value pair. Let us consider a simple example of storing the details of the students along with the marks they have scored with the place in which they are studying. How do we do that? We will have a dictionary in which we have key value pairs where the key significantly denotes the name of each student and the value of those keys again has a dictionary in itself. Yes, we are having a nested dictionary in which the dictionary that represents the value for the key has two keys in itself, one being the marks, the other being the place in which the student is studying. So the marks is going to have another list as its value, which will store the list of scores that they have secured in each of the subjects. Followingly, the second key is going to have string as its value, which denotes the place in which the student is studying. Let us consider another scenario wherein we need to update the following dictionary with a list of marks that's been scored by a new student directly to it via the following instruction. Then we are going to face the error stating James is not a right key that's been present in this dictionary. So how do we mitigate this problem? Is there any other way in which we can make sure that this instruction gets successfully updated or executed in our dictionary? To suffice such requirements, we are going to pick up one of the collections in Python termed as default dictionaries. So how is default dictionary going to behave and how is it going to solve our problem statement? Here we go. Default dictionaries in collection are variations of our conventional dictionary wherein we are going to instantiate the default dict function by passing a function name as an argument to it. Now what sort of functions are we going to pass as argument to this default dictionary? We can pass two varieties of functions to this default dictionary, one being any built-in function or any user-defined function. Let us go back to our problem statement where updating the list of marks directly to a non-existing key in the dictionary errored out. How do we mitigate this problem with the default dictionary? We can solve this in two ways. The first way being create a user-defined function which is just going to return nothing but an empty dictionary when it is invoked. And now create a default dictionary by passing the above defined user-defined function as an argument to it. That's great. Now the instantiated default dictionary, when requested with a non-existing key, for example James, is going to return us an empty dictionary. Whereas in case of a conventional dictionary, if we anytime requested a dictionary with a non-existing key, always errored out with a key error. But that's not the case with a default dictionary. How did this happen? This is purely because of the argument that's been passed for this default dictionary during the instantiation phase. So the thumb rule of the default dictionary is this. If anytime you are going to query a non-existing key as part of the default dictionary, it is going to present as the return value of the function that's been passed as the argument for the default dictionary during its instantiation phase. With these details about default dictionary, let us go ahead and execute the instruction that caused error in case of conventional dictionary, this time with the help of a default dictionary. As a result, we are going to see that the list is getting successfully updated to the default dictionary and it's going to return us the following result without any error. And this mechanism is termed as default dictionaries with user-defined function. We shall now consider another way of achieving the same. This time again we are going to use a default dictionary, but instantiating a default dictionary is done without the use of user-defined function. Then what are we going to pass as an argument to the default dictionary in this case? We are going to pass a built-in function as an argument to this default dictionary, which is nothing but dict. So the argument that's being used in both the cases are callable arguments or callable functions. If we now query the above created default dictionary with a non-existing key, even in this case it is going to return as an empty dictionary. That's purely because the built-in function that is passed as an argument when invoked returns an empty dictionary. We shall now go ahead and execute the statement which caused error in case of conventional dictionary, but here with the default dictionary having built-in function as an argument, will successfully update the list and returns us the following result. And this we can term as using default dictionaries with built-in functions. That's great. We now had a thorough understanding of what are default dictionaries and how do we instantiate default dictionaries, what are the variations in which we can pass the arguments to these default dictionaries, and what is the problem statement that this default dictionary could address when compared to conventional dictionaries. With this brief understanding of default dictionaries, let us jump into a Jupyter notebook to implement them and understand them in detail. Let us create a new Jupyter notebook and rename it as default dictionary. And after this, we shall go ahead and first create a conventional dictionary. How do we do it? We are going to use the variable name as dict1 and the flower braces to instantiate the dictionary. And let's have the first key as name, and we give the name as John, and the second key being age, and we mention it as 25. And now using this dictionary, if we are going to ask for the age, then we are going to get the result as 25. Similarly, using the same dictionary, if we are going to ask for the value of salary, we are going to see an error stating salary is not the right key that is present in this dictionary. To address one such issues, we are going to use collections. So from collections, we are going to import a module termed as default dictionary. Yes, this is what we understood in our lecture session. Let's execute this cell, and we now have the default dictionary available in our program. Before we instantiate the default dictionary, let us create a user-defined function. We are going to name that user-defined function as return int, and inside this return int, we are just going to have a return statement which is going to return us an integer value of 100. Let's execute this cell. Now we are going to instantiate the default dictionary by using the keyword default dict and passing the above created argument or above created function as an argument to this default dict. So now this return underscore int is a callable object, and that's passed as an argument to our default dict. Let's instantiate this by executing this cell. If we further modify this default dict definition by having key value pairs wherein name equal to John and age equal to 25. Let's execute this or re-execute this cell, and we will now ask for the value of name. We are going to see the result as John, and if we request for the entire dictionary, we are going to see that we have age being 25 and name being John. Now let's ask for salary. What are we going to see in this case? In this case, we are going to see the value as 100. Though we did not instantiate with a key called salary, the default dictionary picks up the return value of this function and provides it as part of the key that's not present in this dictionary, by which the default dict avoids the error that we saw in case of a conventional dictionary. We have a simpler way to use the user-defined function in this default dictionary. How do we do that? Let's create a new dictionary, again with the help of this default dictionary keyword. Now this time, we are not going to use the already defined function. Instead, we are going to create the function at the runtime dynamically. How do we do that? We are going to use this keyword called lambda, and using this lambda function, we are going to return the value of 200, along with which we will also create key value pairs as part of this dictionary via tuples placed inside the list. And inside this tuple, we are going to have the key value pairs, the first key being name and the value of it being John, second key being age and the value of it being 25. Let's execute this cell. We now have dict3 present, and this dictionary has the key being age whose value is 25 and key being name whose value is John. Now let's execute this cell by asking for the value of salary again. and we will see what's going to happen. We are going to see the return value of 200 out of this lambda function. So two ways in which user-defined function can be used as part of this dictionary. One is creating a function outside this default dict and using the already created function as an argument to it. And the other approach is to define the lambda function as a first argument inside this default dictionary. That's great. Let us now consider another example where we are going to have a string which is going to have multiple spam text and also a text termed as fruit present in it. We will now use our split function to create a list out of it and assign it to a variable called food_list. If we now see what's there in this food_list, it will be a list consisting of words which were part of that bigger string. Let's say our requirement here is to find the count of a specific word that will be provided by user, before which let us declare another variable called food_count. This variable is going to take the form of a dictionary where the key in the dictionary will be the word which is present in the above list and the value for it would be the count of it. Okay, how are we going to define it or initialize it? We are not going to take a conventional dictionary methodology. Instead, we are going to use our default dict which is part of our collection. And what is the argument that we are going to pass? This time we are not going to define the function. Instead, we are going to use the already available standard function, which in this case would be int. Let's execute this cell and instantiate this variable. We now have the default dictionary created using a built-in function. What next? We are going to have for loop which is going to iterate over this list created above, and we have this food_count variable or a dictionary which is created above whose key would be nothing but the iterator that's used as part of the list. So what are we going to do here? We are going to iterate through every element that's been part of the above list. And then we are going to update this dictionary with key being the elements of the list. And what will be the value of those key? It will be nothing but the count of that specific word which is part of the list. Let us now see what is the result that is present as part of this variable called food_count. It has two keys, one being fruit, the other being spam. And also it has its value being the count of this specific word in the list, which are 1 and 7 respectively. Now what is the advantage of using a default dict over a conventional dictionary? If in this case we are trying to query the value of key spam, we are going to see the value as 7. Now if we try to query a key that's been not part of this specific key list, let's say in this dictionary there is no key called apple, we are not going to see any kind of error. Instead we are going to see the value as 0. There are no words with name as apple. Reason being, we have instantiated this dictionary with argument called int. So by default, it assigns to any unknown key which is part of this dictionary as 0. If it was a conventional dictionary instead of a default dictionary, this instruction would have given us a key error. We shall now query this default dictionary and see what are the key values that it possesses at this stage. We now have 3 keys, one being apple, the other being fruit, the other being spam. And the count of each of them is also provided below. Spam repeats 7 times, fruit repeats just once, whereas apple is not even repeated once, thus the count of it is 0 in the above list. So that means it is going to preserve the keys with the default values as 0 if it's queried at least once. In this case, the default dictionary helps us to count the number of times in which the specific word is part of a list or a string in our program. That's great. With this, we had a great understanding of what is default dictionary, what is its difference when compared to a conventional dictionary, where all it could be used and how it could be used. What are the 2 ways in which we could instantiate a default dictionary? The first method being using a built-in function as an argument to the default dictionary. The second way is using a user-defined function as an argument to the default dictionary. With this, let us wind up our current lecture, and up next we are going to have a look at various other collections that are present in Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through another interesting collection that is present in Python. Before which, let me again take you through what is conventional dictionary. This is how we are going to instantiate a conventional dictionary, wherein it stores key value pairs, let's say in this case, key being the name of person and the corresponding score that he has secured in the specific subject. That's great. Now, If we are trying to retrieve the result out of this dictionary, what is going to happen? It is going to give us the result not in any specific order. What do we mean by that? For example, the above dictionary queried here is listing the values and the corresponding keys in not any specific order. The first key that we are going to see is a last entry that's been made. The second key is somewhere randomly picked again. The third key is also the same, and fourth is also the case. Which just means the retrieval of key value pairs from a conventional dictionaries are always in an unpredictable order. So is there a way to mitigate this? Yes, we have a special variety of collection in Python to mitigate this problem statement. And one such collection in Python that will help us to mitigate the unpredictable retrieval order is termed as ordered dictionary. So instead of defining a default dictionary, we are going to make use of a collection termed as ordered dictionary to retrieve the result in a specific order. For example, the same scenario if we are going to create via an ordered dictionary, when we query the dictionary, we are going to see the result in the order in which we have entered the values. So that just means the John is retrieved first as the first key, followed by which James is retrieved as the second key, followed by which Mary as the third key and Harry as the last key. So this is a very easier way to retrieve the result because we know that we have inserted the data in a specific key value order and we are going to retrieve it in a same order. So that's the reason we are going to make use of a ordered dictionary in Python collection. Let us quickly jump into our Jupyter notebook to see how we are going to use ordered dictionaries in Python. Let us create a new Jupyter notebook and name it as ordered dictionary in Python. Now, once the Jupyter notebook is ready, let us create a simple dictionary which are having keys as the colors and some values as integers that's been assigned to those colors. So let's execute this cell. We will now have a simple for loop which is going to have key value pairs as the iterators. In which object? In the above created dictionary object. So we are going to use the same dictionary object and invoke this items function which is going to provide us set of tuples or list of tuples, and we will just print key value pair for each of the tuples. Let's execute this cell. We are now going to see the result as red 198, green 170 and blue 160. This is again an unpredicted order. Sometimes it could be in a way we have inserted, sometimes it could not be the way in which we have inserted. Just to get a better picture on how the conventional dictionaries does not consider the insertion order into the picture, let's create a new variable as new colors and assign the same key value pairs. But remember, this time we are not going to maintain the order as the same order in which we created the colors dictionary. If we see here, the first key value pair refers to the green color, the second as red color. But in the first case, we have red as the first color and followingly we have the green color. Now, let's execute this cell and we shall now try to compare whether these two values are equal or not. We could get the result as both the values are same. But apparently the order in which they are stored are different for the end user, but internally for the default dictionary, the order does not matter at all. It's just the key value pairs. If they are matching, that just means the dictionaries are equal in nature. And hence, as the order is not considered in the storage time, even during the retrieval time, the order in which it retrieves the result is very much unpredictable and never ever in a specific order. So at any point in time, if we want the order of insertion also to be considered during the storage as well as during the retrieval, we are going to use something called as ordered dictionaries. Where are we going to get this ordered dictionary? We are going to get from the collections in Python a module termed as ordered dictionaries. Let's execute this cell and we now have the ordered dictionary available in our program. We shall now use this ordered dictionary to create a new dictionary in our program which we will term as ordered dict1. Now, how are we going to create an ordered dictionary? We are going to use the above created module or above imported module and place the same dictionary as part of this specific module. Now let's execute this cell. We shall now create another dictionary termed as ordered dictionary 2, wherein we are going to use the ordered dictionary and this time pass the argument in a different order. Let's swap the positions of green and red. And we could now see that there is an ordered dictionary created again. We now have two ordered dictionaries. Let's now try to compare whether they are equal in nature or not. Dict1, is it equal to ordered dictionary 2? We get the result as false because there is a change in the order of key value pairs, though the key and the value are same in both the cases. That just means the order in which the data is stored in a dictionary is considered in case of an ordered dictionary, whereas in case of a default or a conventional dictionary, we never considered the order of insertion. With this, we understood what is ordered dictionary and how is it different from a conventional dictionary. That's great. We shall now wind up the current lecture, and up next we are going to discuss another very interesting, useful and an important collection in Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through another very interesting and useful collection in Python. This time it is going to be a variation of our conventional tuples. So by the way, what is conventional tuple? Let's say we have a simple tuple which is comprising of three different values. One being, let's say, the name, the second being the age, and third being the category of animal. So we are going to name this conventional tuple as animal, which is going to have three values in it, one being the name, second being the age of the animal, and third being the type or category of the animal. Now, if we would want to retrieve data from the above tuple, how do we do that? We are going to use indices to do that. In the sense, we are going to make animal of 0 to get the name of the animal. We are going to write animal of 1 to get the age of the animal. Similarly, animal of 2 to get the specific category or type of the animal. Isn't there a better way to retrieve the data from tuple without just using indices? Yes, that's where we are going to head towards our collection in Python, which is termed as named tuples. So what is this named tuple all about? Let's take the same example which we defined earlier, and now if we would want to rewrite this in the form of a named tuple, we are going to use a keyword or the module termed as named tuple, which will take generally two arguments. The first argument being the name of the tuple, and the second argument will be values which are going to define the fields of the tuple. So the first element is just going to be a tuple name, and the second element will be nothing but tuple field names. So now we have a named tuple object which is termed as animal in this case. We shall now see how are we going to assign values to the tuple field names that are created above. We will straight away use the created named tuple and start assigning key value pairs to it. So what would be the key? Key will be nothing but the tuple field names that we created above, and the corresponding values will be the data that will be assigned for those fields. In this case, we are going to create an instance of named tuple termed as animal, to which the key value pairs will be nothing but the tuple field names, and the corresponding values assigned to it will be the field values. Now we have an instance of animal which is called as Perry, and this Perry object will have keys, name, age and type, and the corresponding values being Perry, 31 and cat. So now we have a new instance of the animal that's created, and to retrieve the data from the above tuple, all we are going to do is use the tuple field names. How do we do that? The instance that we created above is termed as Perry. So we are going to use that Perry followed by the field name that is present as part of that object, which is nothing but age. So Perry.age is going to give us 31 and Perry.type is going to give us cat as the result. So isn't it very much easier to retrieve the data in case of named tuples in comparison to the conventional tuples? Yes, that's true. And also we can reuse the same object to create multiple instances of the tuple. So this category of collection, which is termed as named tuple, makes the tuple operation very much easier and convenient for the user. With this understanding on how named tuples behave, let us quickly jump into our Jupyter notebook to see how do we implement it and what are the different operations that could be done using named tuples. Let us create a new Jupyter notebook and rename it as named tuples in Python. Once we have the Jupyter notebook up and running, we are going to use our collections and import named tuple module. Let's execute this cell. We now have the named tuple module or the function available in our program. Using the above imported module, let us create a named tuple which we are going to name as student, which will be the first argument of our named tuple module, and the second argument will be the field names of the tuple. And how are we going to define them? It will be nothing but a simple string separated by space. In this case, we will have name as one field, age as another field, and finally date of birth as the last field. we will assign this to an object or a variable called student. We now have a name tuple known as student created with this instruction. What is the other way to create a name tuple? We will use the same instruction and modify the second argument of our name tuple function. What will be the second argument? Instead of a simple string, we can create list of elements. The first element being name, second element being age, and third element again being date of birth. This is another way in which we can create a name tuple in Python. Once we have the name tuple created, let us assign some values to it. Let's say we are going to create an object called John. We will use the above defined name tuple, to which we are going to pass some key value pairs. The first element being name will be nothing but John, and second element being age, which will be equal to, let's say, 21, and the third element, which is nothing but date of birth, will be equal to, let's say, 22 Jan 1997. Let us execute this instruction, and we now have an instance of the name tuple student created above. Now there are multiple ways in which we can access the above instance of student tuple. The first way is simply by using the indices. If I want to get the first element details, all I am going to do is execute the 0th index, so that we are going to get the first element of the name tuple. The other way to access the details of the name tuple is use the same instance. Instead of indices, we are going to use the key that's been assigned as part of the name tuple, or the field names which are part of the name tuple. Let's say we want to get the age details. All we are going to do is write john.age, and we are going to retrieve the result as 21. Yet another way to retrieve the result from a name tuple or the details of the name tuple is use the function called getAttribute and use the specific instance of the name tuple as the first argument of the getAttribute function, and the second argument being field name of the tuple whose detail we would want to retrieve. In this case, let's say we would want to retrieve the date of birth of John. Let's execute this cell, and we are going to see the date of birth of John, which is 22 Jan 1997. With this, we understood the three unique ways in which we could retrieve data from name tuples. Let me take you through another example. Let me term a variable as list underscore details, where I am going to have three elements in it. The first element being the name, let's say James, second element being age, which is 22, and the third element again being date of birth, which in this case again will be Jan 22nd, but it will be 1998. Let's execute this cell. We now have a list which is created. Similarly, we will also create a dictionary which is going to store key value pairs. Key being name and the details of it being Mary, age being 23, date of birth is 22 Jan 1995. Let's execute this cell. We now have another dictionary giving us the details of name, age, and date of birth. Using the above defined list and dictionaries, we will be able to create a name tuple. How do we do that? Let us first take the above created list into consideration. We will use the above created name tuple, which is nothing but student, and this student name tuple has a function called underscore make, to which we are going to pass the above created list. And what will happen as a consequence of this? We are going to see another instance of the student name tuple whose values comes from the above defined list. With the help of make function, we are able to create a new instance of name tuple using the data values which are present inside the list. This way we could very easily convert a list into a name tuple. Now we will take the consideration of the dictionary created above. We will again pick up the above created name tuple, which is nothing but student, and pass the dictionary that we have created as an argument to this specific name tuple. And what are we going to see as a consequence of this? We are going to see the result as another instance of the name tuple which makes use of key value pairs out of the dictionary. So now we have the name as Mary, age as 23, and date of birth as 22nd Jan 1995. This way we are able to convert both list and a dictionary to a name tuple very easily in Python. What if we would want to see all the field names of the specific instance of a name tuple? For example, we now would want to see all the field names of this instance John. How are we going to get that? We are going to achieve it by using this keyword called fields. This is going to tell us what are the different fields which are part of this specific name tuple. Let's say we encounter another scenario where we have already defined the data set for the specific instance of the name tuple and we would now want to modify it. The same example of John, where we have already defined the data set in it, we now would get a requirement to modify his name. How are we going to do that? We are going to use this specific function called replace and see what key field or field of the tuple needs to be modified. In this case, let's say we would want to modify its name. So what are we going to do? We are going to pass this argument name and also the value or the new value that needs to be presented here. Let's say we want to modify John to John M. And if we now execute this cell, we are going to see that the specific instance of the student name tuple gets modified with its new value. With this, let us wind up our current lecture where we discussed what is a name tuple and how is it different from a conventional tuple. How do we define a name tuple? How do we access the elements from the name tuple? And what are the different functions and attributes that are available as part of name tuple? And what are the variants in which we can use it? Up next, we are going to have a look at another last category of collections in Python. Till then, take care of yourself. Have a fantastic time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I'm going to take you through another very interesting collection in Python, which is termed as counters. Before which, let us create a simple list, which is going to store the values or the names of different colors. That's great. Now, if we are asked to count how many times each color exists in the above list, we may need something like a calculator or maybe a counter to do this. That's exactly where counters in Python collections comes into the picture. When we have an object like a list or a tuple and it has some redundant elements or repetitive elements, we would want to find out how many times each of those elements are present in our object. That's exactly where counters simplify our development process or the programming operations. Let us now jump into a Jupyter notebook to see how do we use these counters and how are they going to retrieve us the result in detail. Let us create a new Jupyter notebook and rename it as counters in Python. And once the notebook is available and up and running, let's create a simple list which will store the names of various colors, and let's execute this cell. Now we would want to see how many times each of the colors exist in this above list. For which, let us import this module called counter from collections in Python. Once we execute this cell, we now have the counter function available as part of our program. What are we going to do with this? We are just going to use the above imported counter function or counter module and pass the above created list to it. And if we now see the result, it is going to say that the blue is repeated 3 times, red is repeated twice, and yellow is just repeated once. Counter function just made the operation much simpler. Now we will also define another object called as colors underscore tuple, where the colors are stored in the form of a tuple. The same set of colors let us copy and use it as the values for our tuple and execute this cell. We shall now use the same counter module and pass the above created tuple to it, and we will be able to still see the count of elements that are part of the tuple object as well. In general, counter module can be used wherever we are going to store the elements in the form of a sequential order. For example, it could be a list or it could be a tuple. That's great. We now had a good understanding about what a counter is. How is it going to simplify the operation that we require in case of general programming in Python? Let us now wind up the current lecture, and up next we are going to see a very interesting and fascinating collection example and collection module in Python in our next lecture. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through the last part of collections in Python, which is a variant in our data structure called list. So basically, what is a list all about? Let's have a different perspective of list in this lecture first. I'm going to consider the scores that's been secured by different students for a subject, and we have it here. Now I would want to append the score of a new student to this list. How are we going to do? We are going to use this function called append, which is going to add the new score at the end of the list. Similarly, now I would want to remove the newly added score from the list. How am I going to do? I'm going to use this function called pop that is going to remove that last element from the list. More or less, can we consider this list as a single-ended queue? That's true, because we are appending at the end of the list and we are also removing it from the end of the list. So append and pop more or less works at a specific end of the list. So we can probably term it as a single-ended queue. Now, do we have any double-ended queue in Python? Yes, that's where collections in Python comes into the picture. We have a collection called dequeue, which can be considered as a double-ended queue. So how is this double-ended queue going to work? This is just a variation in our default list in Python, where I'm going to again consider the same list of scores secured by different students in a subject, following to which we are going to append a new value, which will sit at the end of the list. Now we also have an option to append at the start of the list, for which we use a function called append left, which will append a value at the start of the list. That's nice. Now we have this function called pop to remove the last element of the list, and we also have a function called pop left, which is going to remove the first element of the list. We now can consider dequeue as a special variation of our list where both the ends of the list can be operated. With this brief understanding on what dequeue is and how is it different from a conventional list, let us jump into our Jupyter notebook to see how do we use this dequeue and how do we operate using this dequeue. So wait for what? Let us jump into our Jupyter notebook to understand them in detail. Let us create a new Jupyter notebook and rename it as dequeue in Python. At first, let us get the dequeue function to our program. From collections, we are going to import dequeue. Let's execute this cell. Using the above imported dequeue function, let's create item list by instantiating the dequeue function and passing list as an argument to it. So I'm going to pass 3 elements to this list and pass that list into this function. Now I have item list. What is the type of this item list? If we try to see its type, we are going to get that it is a dequeue object from collections module. We are aware of the fact that a conventional list can expand in itself by having new elements to it. How do we generally do that? We use a function called append to do that. Is that possible in case of dequeue as well? Yes, it's very much possible to use the same append function and pass an element to it. Let's say in this case, I'm going to use the append function and pass 4 as an argument to it, and it gets appended at the end of dequeue. Additional behavior that dequeue possesses is not just we are able to append the element at end of the list, but also append the element at start of the list by using a function called append left. To this I'm going to pass the argument as 0, and we could see that the first element of the list will be 0 instead of 1. We as well know that a conventional list possesses a method called pop, which helps us to remove the last element of the list. The same is possible in case of dequeue as well. If we now see the result of this item underscore list, the last element 4 is popped out of the dequeue. Additional behavior of dequeue is we could also pop out the first element of the dequeue. How do we do that? We have this function called pop left, which is going to pop out the first element of the dequeue. Now if we execute this, we could see that the output is 0, which means the first element, which is 0, has been popped out of the list or dequeue. This way, in case of dequeue, we are able to operate on both the ends of the list. There are few more functions which are available which will help us to operate on the dequeue, which I am currently not going to cover, but you are definitely free to have a look upon it. If you want to know what are the different functions that are available as part of this dequeue, all you need to do is execute this function called dir underscore or double underscore dir double underscore, and we have a list of functions that are available. Not have a look at something which starts with double underscore, but have a look at the functions that do not have double underscore in their name. For example, append left. Similarly, we have clear, copy, count, extend left, so on and so forth. So with this, we had a brief understanding of what dequeue is and how dequeue could be used and all the available set of functions in case of dequeue. With this, let us wind up our current lecture, and up next, I'm going to take you through some more very interesting and fascinating programming techniques in Python. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I'm going to take you through one of the most heard and most used concept in programming world, which is nothing but object-oriented programming. And we are going to see how is Python going to cater the requirement of object-oriented programming. Maybe most of us would have heard this. Classes, objects, attributes, methods, polymorphism, inheritance. Oh God, What the hell are they? What are they going to do? And how are they going to ease up the life of a programmer during a large, robust application development? We are also going to understand each of these concepts by having a look at a real-world example and a real-world implementations of each of these concepts. Once you understand them and relate to the real-world examples, you will just feel OOP makes developing a program incredibly easier. As easy as eating a banana. To begin with, let us try to understand one of the baseline concepts in object-oriented programming, which is nothing but class. What do we see here in this image? We see that there is a blueprint or a plan of a building that is to be constructed, which has a guest room, living room, balcony, master bedroom, a kitchen, and then an entry point from which the entry to the house is provided. So this is not an actual house or a real house. Instead, it is a blueprint of the house to be constructed. So class is just nothing but a blueprint. We know that blueprint never ever has a real existence. It's just nothing but a model or a recipe of a real thing. Similarly, class is also a recipe or a model using which a real thing can be built. Let us consider the same example of building a house. We first have a class or a blueprint that defines how a house should be constructed. And now using this blueprint, we are going to construct a real house. Which just means we have a class, and in a programming world or in the object-oriented world, we just instantiate a class to create an object. So in case of house construction, we have a blueprint that will help us creating a real item called house. Similarly, in the object-oriented world, we have a class which when instantiated creates a real instance of it, which is termed as an object. Can we instantiate a single class multiple times? If yes, what's gonna happen? Let's have a look at it. Let's say we have the same class and we are going to instantiate it once or for the first time, and we could see that there is first real instance of the class created, which is nothing but the first object of the class. Let's say we are going to re-instantiate the class. That helps us creating the second real instance of a class, which will be nothing but second object of the same class. Now again, if we try to instantiate, definitely it's going to create the third instance or the third object of the class. Thus, a single class can be instantiated multiple times to create multiple instances of the same class. It's very much natural in case of constructing a building, where we may have a single plan that could be used to create multiple buildings as well. With this, we know that class is nothing but an idea or a structure or a plan or a blueprint of a real object. On the other hand, object is a reality of an idea or a physical and real existence of a planned structure. With this brief understanding of a class and an object, let us understand more about them by having a very simple example of a bank account. We have a structure of a bank account here, which is termed as bank account class, which comprises of country code, bank ID, branch ID, so on and so forth. Using this blueprint or the structure of the bank account, or in object-oriented terminology, instantiating the bank account class, we can create a real bank account details of the member. Or that's nothing but creating the bank account object using or instantiating the bank account class. In this case, country code, bank ID, branch ID, so on and so forth, which are acquired from the class, are termed as attributes. Let's have some detailed understanding on what are the different attributes that are present in object-oriented programming. Attributes that define characteristics and properties of an object or the instance of a class, which are specific to each of the objects that are created for a class, are termed as instance attributes. For example, in the case we have considered, which is nothing but the bank account creation example, the bank ID, branch ID, account number and account name could vary across different bank holder details or different bank account member details. So that's the reason we term it as an instance attribute, which may change across different members of the bank or different objects of the bank account. The other category of attributes are termed as class attributes. These class attributes remain same across the objects and are specific to each class. For example, in the case what we have considered, which is nothing but the bank account and the bank account details creation, we have two attributes termed as country code and currency code. Let's say this bank operates in one country, then the currency code and country code values remain same across different instances of the class. So to brief it again, what instance attributes are and what class attributes are, here it is. Instance attributes are nothing but the attributes that are specific to each of the objects, and the values of those attributes vary across different objects of the class. Then it's termed as instance attributes or object attributes. Then the other category is called as class attributes. These attributes are specific to each class. In the sense, let's say we have 10 different objects for this class. Then across these 10 different objects, the values of the attributes remains same and can only be modified by the class, which will reflect across all these 10 different objects. We will understand and implement what instance attributes and class attributes are, how do they differ in detail in our coding lecture. We till now had a very brief understanding of what attributes are and what objects and classes in object-oriented programming are. Let's continue this and try to understand another very interesting concept in a class or an object-oriented programming world. We understood what attributes are and what are the different variations in them. Now let me take you through one of the other very interesting and important concept in a class, which is called as methods. So what are these methods? Methods are nothing but functions that are created inside a class to operate on top of the attributes. It could also take some arguments which are provided by the user and work along with the attributes that are defined inside the object or a class and give us some result. So in general, a simple method is nothing but a function that will be created inside a class to write some business logic by using the attributes that are defined inside the class or inside an object. Let me take you through a special method in object-oriented programming, which is called as constructor. As you see here, constructor is also a method, but that's a very special method. Starting with its naming convention, it has its own characteristics to define a class and an object. A constructor is a method whose name starts with double underscore or underscore followed by init and ends with again double underscore. Speciality of this constructor method is this method will be implicitly invoked when a class is instantiated or when an object is formed. Let us understand what it means in detail now. Let us consider the same bank account class, which comprises of a constructor along with the other methods that operate on top of attributes. We shall now instantiate this bank account class, which lets us creating a bank account object in the memory, which will have the methods that operate on top of attributes. During this instantiation process, we will also be implicitly invoking underscore init function. So this function, which is termed as a constructor, will be implicitly invoked in the background during the instantiation process. So now what will this constructor do? This constructor will just create the attributes inside the object memory, which are termed as instance attributes. Why are they termed as instance attributes? That's purely because of the usage of this keyword called self. Now what is this self all about? Is this a user-defined variable or a built-in keyword that's present in Python? We will understand in detail about what is self and how do we use it in object-oriented programming of Python. We could now confidently say that we know something about classes, objects, attributes, and methods in object-oriented programming of Python. Let us now jump into our Jupyter notebook to understand how to create a class, how to create an object, how to create and use class attributes and instance attributes, how to construct a constructor, how to create and use methods, and finally what this self is all about and how does it behave. With this, let us wind up our current lecture, and up next we are going to take a look at all the listed details above in our Jupyter notebook. So till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to have a look at the detailed implementation of what we learned in our previous lecture about object-oriented programming in Python. So wait for what? Let us quickly jump into our Jupyter Notebook to begin our journey of implementing object-oriented programming via Python. Let us create a new Jupyter Notebook and rename it as Object-Oriented Programming in Python. So once the Jupyter Notebook is up and running, let us see how do we at the first create a class in Python. Let us take a very simple example of a class, which in this case is car, which will have its own set of attributes defined in the class. So how do we write a class or how do we define a class? Here we go. We have this keyword called class, which is going to define what class we would want to have in our program, followed by which the name of the class. Let's say for this example, we are going to name our class as car. So how do we write a class? We will have the keyword class first, followed by which the name of the class. And this name is a user-defined name. Followingly, we will have parenthesis and colon. Now press enter or line carry H. This will append certain indentation in the class by our Jupyter Notebook. So now this indentation will define the scope of our class. So any instruction or attribute or functions that needs to be defined inside a class requires this indentation, which will be taken care by our Jupyter Notebook. So now this indentation will define the scope of our class. To start with, let's say airbag is one of the characteristics or attributes that's been present in this car. For now, we will say this car does not have any airbag. So I'm going to set this as false. Let's consider this attribute to be Boolean in nature, followed by which 4-wheel drive. Let's say this is true, and another attribute which is known as car model is defined as sedan, which is in this case a string, and the last attribute, which is nothing but number of doors present for this car, is 4. So let's execute this cell, and we now have a new class which is termed as car present in our program. So the above defined class is nothing but a structure or an idea or blueprint of a real object. So it's not a real object as such, but instead it's a metadata or a structure or an idea of a real object. So how do we create a real object out of it? This is how we are going to create a real object. Let's say I want to create a Ferrari car. How do I create a Ferrari car? I want to have the Ferrari car of the same structure which is defined above. So I'm just going to use the above class and instantiate that class. So just remember this word. We are going to instantiate a class car to create an object Ferrari. So let's execute this cell. We now have a Ferrari of type car that's present in our program. We can easily verify that by passing the above object into this function called type and see what type is this Ferrari all about. This Ferrari is simply nothing but a type of car class. So the data type or the type of this above object is car. If you remember right, in the last lecture we understood there are certain set of attributes that are associated with class and object. So the above defined set of attributes in this case are termed for now as class attributes. That's purely because these are the attributes that are defined inside the class, and now the object Ferrari can also access these class attributes. So class attributes in general are specific to a class and are shared across all the objects for that class. Let's say in this case I'm going to use Ferrari.airbag. So I could see that we have a variable or an attribute airbag associated with this car Ferrari, which comes from this class and whose value is false. Similarly, the other attributes like 4-wheel drive can also be accessed via this object called Ferrari, which is nothing but true for this object because it's also true for our class attribute 4-wheel drive. So that just means the attributes that are defined inside the class are also accessible by the objects that are created for that class. So now, are these objects class attributes or instance attributes? They are definitely class attributes because they belong only to this specific class. So does it mean objects cannot access them? No, they can as well access, but when they access these attributes, they are accessing the class attributes. Instead, they are not accessing their own object attributes. So let me tell you how is this possible, or how do we really make a difference out of it. Now we are accessing these two attributes, airbag and four-wheel drive. Let us try to check what is the memory value for these two attributes. If we try to see the memory value of these attributes, for example, in this case, we are checking the memory value or the ID value of airbag attribute accessed via this Ferrari object, which is nothing but this specific value. Let me also try to access from the car class the same airbag attribute. We will definitely see that both the memory locations are same, which just means the attributes which Ferrari and car both are accessing are the same attribute, which is nothing but the class attribute air_bag, which clearly indicates that the current attribute which is accessed is not specific to the object. Instead, it is specific to the class, and hence it's called as a class attribute. That's great. So now, how do we have or create an object attribute or an instance attribute? That's very much simple. Let's say for this specific object, I want to create airbag attribute. We can do it by just assigning this specific airbag attribute with a new value called true, or it could be even a new value called false. So when we do any assignment to an attribute accessed via this object, the attribute that gets created will be specific to that object. So which means in the memory of the object there will be an attribute that's owned by this specific object. So now if we see what's the value of Ferrari airbag, it will still show false because we have assigned it as false. If we now assign it as true, we can see that the value that's associated with air_bag for Ferrari object is true. Whereas for the class car, what's the value of air_bag? It is still false because air_bag attribute owned by Ferrari object is different from air_bag attribute owned by the car class in itself. So to be more precise and clear, after this assignment instruction, we will now have a new attribute or an attribute allocated with new memory for this specific object Ferrari available, and that will differ from the class attribute air_bag. So now we have two categories of attributes, one being the class attribute, which is there in the instruction 24, and the other one being an instance attribute, which is there in instruction 23. How do we verify it? Let's again go back to our ID function and say Ferrari.air_bag. It will give us a value. Similarly, we will use the ID function to find the air_bag's memory location for the class car. We now clearly see that the value which is present in instruction 26 and instruction 25 are very different. That means airbag for Ferrari object is owned by Ferrari object in itself, and airbag present for class car is owned by in itself, which we term it as a class attribute, and the other instruction which is written above where air_bag attribute is owned by the object is termed as an instance attribute. So in this program we have both instance attribute as well as class attribute available. Let us create a new object which we term it as BMW, which will be created out of the same class car, and now we shall see what's the value associated with air_bag. We could see that the value associated with air_bag is false because BMW is now referring to class attribute air_bag, because there is no new instance attribute at this stage available for BMW. It will definitely look for the class attribute. So the flow goes this way. If there is any attributes requested from this specific object, it looks for that specific attributes within itself. If it's not available, it just goes to the class and checks, are there any class attributes available with this name? If yes, it will pick it up from there. Again, if I want to make an attribute available specifically to that object, all I need to do is write this object name followed by this specific attribute and assign it some new value. Let it be true or false. Let's say in this case it's false. So this way we are able to now assign a new attribute or an attribute specific to this object, which we term as instance attribute. How do we avoid this? I want certain set of attributes to be available specifically to a class, and certain other set of attributes to be specifically available for our object. So that should be done inside the class in itself instead of explicitly assigning an attribute a value via that object. Is there a way to do it? Yes, we definitely have a way to do that. Before that, let me take you through something very interesting and important in object-oriented programming, which is called as methods. Let us consider the same example of a car and the set of attributes assigned for them. Let me redesign the same. We are going to recreate a class car with having the car model, doors, ground clearance, four-wheel drive, wheelbase and brake system as the attributes. And importantly, the difference in this class is we have another function or method which is called as met_accident. So inside this function, I'm going to have an attribute, or I would not want to define it as an attribute. Instead, I would want to say it as a variable and assign it as true and write a print statement which says met with accident, along with which we will also want to print the result of the above defined variable, which is airbag_used. Let's execute this cell. We now have a new class car which has the above defined set of attributes and very importantly a method termed as met_accident. We shall now create a new object, let's say termed as Benz, and we are going to instantiate it with this class car. That's great. Now let's execute the method or invoke the method via this object called Benz and execute this method by calling it. We now have the result saying met with accident true. Now, can we access that specific attribute, or as I said, I don't want to define it as an attribute, instead a variable airbag_used? Let's see that. If I try to access this airbag_used variable, we get an error stating car object has no attribute airbag_used. Same error would be seen if I try to use it from the class car as well, because airbag_used variable is specific to this function or the method, and it's neither accessible via this class nor via the above created object. Instead, scope of this variable airbag_used is only within this function met_accident. With this, we now had a detailed understanding of how do we create a class, how do we instantiate a class to create an object, how do we define attributes within the class, and what is the difference between a class attribute and an object or an instance attribute. And also we very importantly learned how do we define a method inside the class and how do we access that method from an object. But what we did not really have a look at is we did not understand what is this self all about and why do we define this self and how do we use that self. Trust me, we are going to have a detailed understanding on what this self is all about in the coming lecture. And another important fact is I did not show you how do we create both class attribute as well as instance attribute inside the same class. Instead of explicitly assigning the attribute or the value from an object, is there any other way in which we can define the instance attributes inside the class itself along with the way we define a class attribute? Yes, we do have a way to do it. So all these things will be discussed in detail in our coming lecture. So with this, let us wind up our current lecture, and up next we are going to have the detailed and advanced explanation and implementation of self, differentiation between the class attributes and instance attributes in more details and defining them in detail. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a complete guide for beginners. In this session, we are just going to continue from where we stopped in our previous lecture. So let us quickly jump into our Jupyter notebook to resume from where we stopped in our previous lecture. We in our previous lecture understood how do we create a new class, how do we create attributes inside a class and assign values to them, how do we instantiate a class to create an object, how do we access class attributes from an object, and also how do we define or create instance attributes or object attributes. That was done by assigning the value of an attribute from an object. We were able to create an instance attribute, right? And we were able to clearly see the difference between an instance attribute and a class attribute. And we also understood the flow of accessing an attribute from an object. And we also had a look at how do we define a new method inside a class and how do we access that method from the object of that class. But what we did not really have a look at is, what is the self all about? Where did we define it? How are we using it? And why do we need the self all about? So these are few things which we did not understand or had a look at, which we are going to look at in detail in this lecture. We realized in our previous lecture that defining a variable inside the specific function or the method scopes its access only to this function, which means this variable was never ever accessible either via this class or the object which was initiated using this class. Keeping this point in mind, let me take you through another very interesting concept of what is the behavior of using self in class or an object-oriented programming, and how is it going to be very useful and handy when we are defining multiple objects for a class. Let us modify the already created class definition as follows. If we could see the difference in this class compared to the previous class is the specific instruction. And of course the print statement is removed, but let's keep that aside. And the major differentiating factor between this class and the previous class is inside the function we had defined airbag underscore used attribute this way in our previous class, but now I'm assigning self.airbag underscore used to be true in this case. Okay, what is the use of it? First of all, why do we need to even write it this way? Let me take you through that concept in a while. Before that, let me instantiate this class. Before that, let me even execute this cell to create a new class, and we will have a new object called Ferrari, which is created using the above created class. Let's instantiate the above defined class to create a Ferrari object. We now have the Ferrari object created out of the above defined class. Let's say if I now would want to access the attribute airbag underscore used via the new object Ferrari, is that even possible to do? Let's execute this cell. We will have an error stating car object has no attribute called airbag underscore used. Of course, the same error would be seen if I use car class and try to access airbag underscore used. Now, let me go ahead and execute Ferrari dot met underscore accident instruction. What is this going to do? This met underscore accident is a function which apparently has one argument, but here I have not passed any argument. Let's keep this in mind and I'll come back to it later and explain why did we not pass any argument. So let's keep it aside, and inside this function met underscore accident I have an instruction called self.airbag underscore used equal to true. And what is this going to do? Let me show you. Now let me re-execute the same instruction Ferrari.airbag underscore used. Wow, we don't see the error now that we saw in 47th instruction, but instead we see the value to be as true. Do we see the same result when we use car.airbag underscore used? Definitely no. That's because this airbag underscore used attribute is specific to this instance or object, but it's not part of the class, and hence we see the error when it's executed from the class, but it goes through fine and gives us the result when it's executed from the object. So we could clearly say that airbag underscore used attribute in this case is an instance attribute belonging to the instance Ferrari, but it's not a class attribute at all, and hence we saw the error in the second case. Now, how did this function work? Because we ideally were supposed to pass an argument, but we did not pass any, but still the function went ahead successfully, and it helped us creating an instance attribute for this specific instant. How did this work and how did it actually happen at the back end? Let's have a look at it. Before we get into that, let me take you through a very simple and useful attribute, which is a default attribute present for the object as well as the class, which is nothing but double underscore dict double underscore. So what are we doing here? We are just using this underscore dict underscore on top of an object that will return us the list of object attributes or instance attributes specific to that instance. So for Ferrari object, we just have one object attribute or instance attribute, which is called as airbag underscore used. Now we will try to apply the same attribute or the built-in attribute dict underscore on the class to see what are the default or the available set of class attributes. Let's not get into the details of attributes with naming convention as underscore. Instead, let's just go through the attributes that have the generic user defined names. For example, brake underscore system, car model, doors, four-wheel drive, ground clearance, met underscore accidents. So these are the set of attributes and methods that are available as part of this specific class. But we do not see airbag underscore used attribute which is present as part of this class. So that just means airbag underscore used is not yet part of the class attribute. Having a sneak peek at this built-in dictionary available for both object and the class, let's go back to our initial discussion of what is the behavior of self all about. Let me pick up this class and recreate it here again. Let's execute this cell. Now I'm going to create the first object for it, which is nothing but BMW, using the same class structure defined above. Now once the BMW object is created, let's use it and invoke the method met underscore accident. And definitely we are not going to pass any argument to it. Let's execute this cell. And we now know that this function got successfully executed. But what exactly happened at the back end? Let us try to backtrack and understand what exactly happened. When we say BMW.met underscore accident, any function that's created inside a class would definitely require one argument. But trust me, we are not going to explicitly pass that argument here. Instead, this is very similar to writing it this way and passing the same argument to it. It ideally behaves this way when we try to invoke a function or a method inside a class via an object. The first argument will implicitly or default value of the first argument will be the object in itself. So self is going to take the role of the object who is calling this function, which means self.airbag is nothing but BMW.airbag equal to true. Self, let me try to reiterate, self is just going to enact like the object that's been present. Or I would even want to say self is a proxy of the object. So when we say BMW.met underscore accident and we don't pass any argument to it, it just means the object in itself is implicitly passed as one of the arguments. And that's the reason when we say self.airbag equal to true, it just means BMW.airbag used equal to true. So any assignment via self to an attribute will be nothing but assignment to the object who invoked it. Let me reiterate again. When we invoke any method from an object, the first argument which is present inside this specific function definition will be nothing but the object who invoked that function or the method. So we don't necessarily need to pass the argument here. In fact, we should not pass the argument here because it implicitly takes the value of the object who invoked that function. Let's say accidentally we try to pass something. What's going to happen? Is it going to replace that argument first element or whatsoever? Definitely not. Let me try to give the value as 100. Let's say within single quotes and execute this cell. We see an error stating met underscore accident takes one positional argument, but two are given. No, we did not definitely send two arguments. We just sent one argument. But why do we see this error still? Because along with this 100, there is also another object that is passed implicitly without our knowledge. It is implicitly passed. Whether we send one argument or not, there will be a default argument that would be passed along with this function call. So two values are seen here because we did not pass two values, but implicitly there was a value seen at the first and there is a second value which is not possible to be passed to this function call. Thus we can take it for granted that the first argument or the argument that's available in the function definition at the first position will always be the object who is going to invoke that specific function or the method. Now, should it really be self itself, or can we give any user defined name? Let's try that. Let's say instead of self, let me write as test, and I as well write the same test here also. Let me just execute this cell and now create a new instance of car, which is, let's say, Benz. And now we will try to invoke the same met_accident here as well. What's going to happen? Do we see any error? Definitely not. Self is one of the naming conventions that's being used for the default argument of the function, but we could still replace that self with any user defined name. It doesn't matter at all. If you are coming with a background of C++ or Java, we would have definitely come across this specific keyword called this operator. So in Python, whatever we call it as self is very similar to this operator in Java or C++. Self behaves very much similar to this operator. So the convention is always use self, and the self argument will be nothing but the object who invokes that function. So mandatorily we are supposed to use one of the arguments during its definition. Let's say I'm not going to use this. What's going to happen? Let's execute this cell and redefine the class, and we will instantiate this class again for the same Benz object, and we will try to invoke the same method that we invoked earlier with the Benz object. But this time, trust me, we are going to see the error, and the error says that the met_accident takes 0 positional arguments, which means it does not have any arguments at all, but one was given. Where did we even give that argument? As I mentioned earlier, we don't need to explicitly pass any argument. Instead, invoking a method from an object in itself passes the object as one of the arguments. So when it tries to pass such argument, there is nobody to take care of that argument because we did not define anything during its definition. So we cannot create a function without an argument. So it's mandatory that we need to have at least one argument defined here during the function definition, but we don't need to pass a value for that argument. Instead, when we try to define it with one argument, when we just invoke it, the object in itself would be passed as an argument to it. So with this, we had a clear understanding of what this self is all about and what will it do. So when we say self.something, this is very similar to writing it as Benz.airbag underscore used equal to true when we try to invoke this met_accident function from Benz object. Again, this instruction will implicitly ensure that there is a generation or creation of an instance attribute or an object attribute who invoke this specific method. So this instruction will give rise to an instance attribute for the instance who invoke this method. When we try to redefine this cell and instantiate the class and invoke this specific method via Benz object, we will now see by saying _dict what are the key value pairs or what are the instance attributes that are present. We could clearly see that airbag_used is an instance attribute. That's because of this specific instruction. And if we now use class followed by _dict_, we could clearly see that there is no class attribute named as airbag_used. So now what I'll do is just a small modification. Let me try to invoke met_accident from a class itself instead of an object. What will happen in this case? We could see that met_accident is missing one required argument, which is nothing but self. So whenever I try to invoke this specific method from a class, the argument which is supposed to be passed is never ever passed unless we pass it explicitly. So that means it's only in the case of an object when it invokes this method or the function, it passes the first argument implicitly as the object itself. But if it's a class who is invoking this function or the method, then the first argument is never ever passed. So can we explicitly do that? Yes, it's very much possible. Let me try to pass the argument as the class itself. What's going to happen? This instruction gets executed successfully. Now let's see what's the value of this dictionary, _dict_. Do you see this? There is a class attribute called airbag underscore used, which is created. That's purely because met underscore accident took the argument as class and it defined class dot airbag equal to true. So this is how we are able to create a class attribute as well via this specific method. Now let me try to create a new object Audi by using the same car class, and we could now see that there is an attribute called airbag underscore used that is already present here. Now if we try to see the ID of airbag underscore used, which is present for this object Audi, this is the value. Similarly, if I see the memory location of airbag used attribute for the class, this is very much same as what is seen in case of Audi. That's because Audi, when instantiated, picks up all the class attributes as well to be accessible. So when I try to access airbag underscore used from Audi, it just points to the class attribute. To reconfirm it, we can use underscore dict built-in attribute that will list what are the key value pairs or the instance attributes that are available as part of this instance Audi. Currently there are no instance attributes because everything that it has is all the class attributes that could be accessed from the object. So now if I want to create or have an instance attribute, all I'm going to do is execute this function met underscore accident. Now this met underscore accident, we know that it will have self in itself, so it will be Audi.airbag used equal to true. Now let's go back and see, are there any instance attributes that are available as part of this Audi instance? Now it's available because we have executed met underscore accident, which had an instruction self.airbag used equal to true, which in this case became Audi.airbag underscore used equal to true. So now we have instance attribute available as part of Audi object. And the other important occasion where self is going to come in handy is when we are trying to instantiate multiple objects for the same class. Let's say I'm going to redefine the car class with simple method and a simple attribute. So at this stage we have a class car which has class attribute airbag underscore used equal to false. So this is a class attribute, and we have a method or the function which is going to write it as self.airbag underscore used equal to true. Let's execute this cell. We could clearly see that this specific class via this underscore dict underscore, we can clearly see that this specific class has one class attribute which is nothing but airbag underscore used, which is assigned to false, and it has one method met underscore accident. Now what we will do is we will create two objects, one being Jaguar using the same car class, the other one being Benz using the same car class. And let's say ideally this should not happen, but hypothetically let's assume Benz car meets with an accident by invoking this function Benz.met underscore accident, and Jaguar remains intact. So now if we try to see the value of airbag underscore used for the specific object Jaguar, it says it's false. It's never been used, and it points definitely to the class attribute airbag underscore used. Whereas in case of Benz, let's see what's the value of airbag used. It points to true, and this airbag used is an attribute that belongs to this specific instance Benz. We could very easily confirm it from the object by using built-in underscore dict. We see that there is no key value pair or instance attribute for this instance Jaguar. Whereas for Benz, we see that there is an instance attribute called airbag used. So any newly created object now will not have an instance attribute airbag underscore used within itself, but instead it will have, or it could access airbag underscore used from the class attribute airbag underscore used. So any newly created instance of the class car will be able to access airbag underscore used, which will be set to false until and unless it meets with an accident. When it meets an accident, then definitely it will have its own airbag underscore used attribute or instance attribute, which will be set to true. With this, we had a detailed explanation and thorough understanding of what self is all about and how self is used in Python object-oriented programming. With this, let us wind up our current coding lecture, and up next we are going to have a look at various other important and useful capabilities in object-oriented programming in Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to have a discussion about one of the very interesting and important concepts in Python object-oriented programming, which is called as constructors. We realize that constructors are a special variation of methods in Python, but we are now going to understand how are constructors going to be defined and how is it going to be used during the instantiation process. So wait for what? Let us quickly jump into a Jupyter notebook to implement constructors in object-oriented programming of Python. Let us create a new Jupyter notebook and rename it as constructors in Python. Once the notebook is up and running, let us create a very simple example of a car class, what we defined in our previous lectures as well. Here we go. Let's have a keen look at what exactly we have done here. We have a car class defined. Inside this car class, we have something called as double underscore init double underscore. And we inside the parenthesis have something called as self. We now know what this self is all about. Double underscore init double underscore is a special method inside the class. And this special method is termed as a constructor. And the behavior of self in a constructor will remain same as what it behaves in case of a normal regular function or a method inside the class. Let me write a simple print statement for our reference inside this constructor. Constructor is called. That's great. Let's execute this cell. We now have a car class within which a constructor is defined. Now I'm going to create a new car object, which is Ferrari, by instantiating this car class. Let's see what's going to happen. Do we see here we have a print statement which is also an output of this instantiation process, which is saying constructor is called. Why did this specific print statement occur? We did not anywhere explicitly call this double underscore in double underscore, but the instantiation implicitly would invoke this method called constructor, and that constructor when executed will help us in assigning or creating the attributes for this object. And we are aware of the fact that the nature of self will help us assigning these attributes to the object who invoked the method. Even in this case, the constructor invocation will belong to the object which instantiated the class. So this will be nothing but Ferrari dot underscore init underscore. So now the constructor, when it's invoked and it's executed, the self will always be pointing to the object which is instantiated or created here. To clarify the same, let's use underscore dict underscore, which is a built-in dictionary which will have the key value pairs or the attributes which are belonging to this specific object. So the Ferrari object has airbag used, brake system, car model, doors, four-wheel drive, ground clearance, and wheelbase as its attribute. How did this happen? This is purely because of the constructor which when invoked created the instance attributes for this specific instance called Ferrari. At the same time, if we try to see what are the class attributes that are present for the specific car class, we don't see any of the above defined attributes belonging to this class, because as I mentioned earlier, they are all belonging to the specific object called Ferrari. We can also define certain set of user defined arguments for a constructor. Let's recreate the above class, and we will have the constructor in a modified fashion where we have one of the other arguments along with the self, which is called as model. So the value of the model or the default value assigned to the model is sedan, and this specific model argument is assigned for car underscore model. Let's execute this cell. And we now have the new car class created in this program. Let us make use of the newly created car class and instantiate it to create a new object called Benz. Now we are going to do this. We will now see that Benz has certain set of attributes which are defined as instance attributes, which could be seen in this underscore dict attribute. So we now have these instance attributes that are available as part of the Benz instance. We now had this input argument called model, which had its default value as sedan, and hence we now have the car model type as sedan. Is there any way in which we could modify this value of model and pass the user required value when we are instantiating the class, which implicitly would call the init with that new value? Yes, it's very much possible. How do we do that? We will have something called as Benz new, where we are going to reinstantiate this car class with a new value called hatchback. When we pass this new value of hatchback as an argument to this car class, what's going to happen? We will now see the value of car model for this new Benz car. We could clearly see that the car model is having the value of hatchback instead of sedan. That's because when we are instantiating the car class, when we pass an argument, it will be placed in the underscore init function. That's because the first ever function that would be executed when we are instantiating a class will be nothing but the constructor. So in general, any value that is passed as an argument to a class during its instantiation will always go to the constructor. So when we want to pass any value dynamically to the user defined argument which is present as part of the constructor, all we are going to do is we pass that value to the class during its instantiation, which will in turn pass it to the init function or the constructor which is defined inside the class. With this, we had a thorough understanding of how do we define a constructor and how do we instantiate a class which in turn will call the constructor, and how do we pass the argument values to this constructor from the class. With this, let us wind up our current lecture, and up next we are going to have a look at other details and implementation of object-oriented programming in Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through another very important vertical of object-oriented programming, which is called as encapsulation. So what is this encapsulation all about? What does it really mean? Here we go. First of all, what does encapsulation in general means? Let's consider a very simple example. We have some ingredients and we have an outer shell that's present as well. So we now have two components, one being, let's say, the ingredient of a medicine and the other being an outer layer within which the medicine will be placed. Now coming back to the encapsulation in terms of object-oriented world, we will consider that ingredients to be as the variables of an instance, that's nothing but instance attributes like temperature or pressure of atmosphere class, and the outer shell can be considered as the methods or the behavior of those attributes like set temperature. So set temperature could be a method which will modify the instance attribute temperature. Now when we try to make this ingredients sit inside this outer shell or the cover and cover it up with the entire wrapper, that's termed as encapsulation. So we are going to encapsulate private variables in a public method. What did we just hear now? Did we mean the following? Where we have public variables and public methods, and also private variables and private methods. Yes, that's very much right. Encapsulation object-oriented programming is all about public and private variables and methods. So we now have four categories, one being public variable, the other one being private variable, similarly public method, and the other one being private method. What are these public and private methods and attributes? Here we go. Public method is simply nothing but a method that could be accessible from anywhere. That means objects of a class can directly access these methods without any restrictions. Whereas in case of private methods, they are accessible only in their class, which means I can access the specific method within the class alone, or it could be accessed from another public method. So an object cannot directly access this method. Such methods are called as private methods, and they start with double underscore as their naming convention. And again, public variables are something that could be accessible from anywhere by any of the objects without any restriction. Whereas private variables, they are only accessible within their class or by another public method. It again starts with double underscore in its name as a convention of denoting a private variable. But let me hint you another very important aspect in Python. There are really no public and private keywords in Python. What? Then how do we really define private and public objects or private and public methods and variables in Python? We will see how do we do that in detail in our Jupyter notebook. Let us quickly jump into our Jupyter notebook to implement encapsulation in Python programming. Let us create a new Jupyter notebook and rename it as encapsulation in Python. So once the Jupyter notebook is up and running, let us go ahead and create private variables and private methods. We know that what public methods are all about and what public variables are all about. In our previous lectures, whatever the variables and methods that we created, they all belong to the category of public variables and public method. So in this coding lecture, we are going to focus on implementing a private variable and private method. To start with, let's take the example of the car class, within which we will have certain set of methods. We will define first method as a public method. How do we define a public method? We are going to use this keyword followed by the name of the method, driving, and we will have self as one of the argument, the other one being, let's say, name. And inside this we will have a print statement stating name is driving. So name being the input argument, we will have the print statement involving a string and the input argument. Along with this, we will also have some other set of methods, one being a constructor and the other being a private method. We know that when we want to define a private method, we are not supposed to give the name as a regular method name. Instead, we must use double underscore or underscore followed by the name of the method. Let's say the name of the method in this case is software update, which will have one of the arguments definitely as self. Now we will have the print statement stating software update is in process. Once we have a public method and a private method available as part of our class, what we are going to do is let's execute this cell. We now have a class defined. Let's instantiate this class. The name of the object being Benz. Let's instantiate the class. We now have a Benz object which will take the metadata or the structure of the above defined class. Using this object, let's try to invoke one of the methods that's available here, which is called as driving. It requires at least one argument, which is name. I'll name it as John as the input value for the argument. Now when we see the result, we get John is driving. Now on the same lines, if I try to invoke the method, private method software update, we are going to see an error stating car object has no attribute called double underscore software update. So the object cannot directly invoke a private method which is created inside a class. And this is how we are going to encapsulate methods in classes. So now what are the ways to access this software update private method? Let's have a look at it. Let's redefine this class, and in this redefined class we will have a public method as well as a private method available. We will also have a constructor defined now, which will definitely have one of its argument as self, and also we will have the execution or the invocation of the private method inside this specific constructor. How can we invoke the above defined private method? We will use the self operator, which is defined as an argument to this underscore underscore init function, and invoke software update function using this self operator. Let's execute this cell. We now have a car class which is defined above. We will create a new object called BMW using the above defined car class by instantiating it. We could see that the software update is in process. So which means when we try to instantiate the car class, we were automatically invoking the specific constructor. And that's how the constructor behaves. And the constructor implicitly or internally invoke this private method software update. So the other way to do this is we could also have another public method, public update, which will have an argument called self. which will internally invoke or call the above defined private method software update. So if we write it this way, we can as well create the object, and we could also explicitly invoke software update method via public update method. Here is another way in which we could really invoke or execute private method via a public method. So the two ways to do that. One is put the private method execution inside a constructor, or define another public method like how we have defined here, within which we try to invoke the private method. So with this, we understood how do we create a private method and how do we access or use the created private method. Let's go ahead and understand how do we define or implement private variables or attributes and how do we use them. So let's recreate the same class car. Inside this class car, we will have a constructor which is defined this way with self as one of the argument, and inside this constructor we will create an instance attribute whose name is max speed, and we would want to make this max speed attribute as a private attribute. How do we do that? We know that for a private attribute as well, we will be using double underscore or underscore, and we will have the max speed set to, let's say, 10 units. And let's go back and create a new public method, which is nothing but driving. And we will have a simple print statement which just lets us know what's the max speed. Max speed of this car is self dot underscore underscore max speed. So now we have a constructor defined which will have an instance attribute called max speed, which is private in nature, created, and also we have a public method which will access the above created private attribute. We know that max speed attribute is integer in nature, so to concatenate it with a string, we need to convert this max speed attribute into a string. So let's execute this cell now. We now have a new car class defined. Let's create an object out of that class by instantiating it. We will now have an object called Audi, which will have one method which is public in nature, which is called as driving. So let's invoke that driving method from this object, and we will see what's going to happen. We will see that max speed of the car is 10 units. We could now successfully access the private variable which is present inside this class via a public method. But if we any day would want to access that specific private variable via the object directly, let's say in this way as max speed from Audi object, we will definitely not be able to do that because the car object has no attribute termed as underscore max speed. So directly we could not use a private variable from an object. We now understood how do we create private variables and private methods without the use of public and private keywords. But as I mentioned, there are really no public and private attributes and methods in Python. What did I just mean? Yes, that's true. They are not really hidden, instead they are just renamed. For example, if I try to see the built-in dictionary which is available as part of the object, we could see that the attribute or the instance attribute of the instance Audi is renamed from double underscore max speed to underscore car double underscore max speed. So which means all the private attributes or variables will be prefixed with underscore followed by the class name. We now have the instance attribute max speed renamed to underscore car double underscore max speed. Instead of accessing max speed attribute with underscore max speed, if we try accessing it with underscore car double underscore max speed, we will still be able to access it. So the private attributes are really not private, but it's just a convention to make sure that we don't accidentally use it or accidentally modify it from the object directly. And hence we have this convention of having double underscore to make sure it is considered as a private access specifier in case of object-oriented programming. Same is the case with private methods as well. Let's try to recreate the same private method that we created in our first example, where we have the class car which has a private method termed as software update. Let's execute this cell. If we now see the details of the above defined class by using the underscore decked underscore attribute, we will see that we have a method called software_update, which is renamed to _car _software update. So this method or the function is considered as a private method because of its naming convention, which is nothing but _ followed by the method name. But internally it's not really hidden. Instead it's renamed to _class name followed by the method name. So internally again, private methods are really not private or really not hidden. Instead they are renamed so we do not accidentally use it. With this, let us wind up the current lecture where we try to understand what the access specifiers are and what are the variations of access modifiers or access specifiers that are present in Python. We discussed about 4 variations in encapsulation. One being public method, the other one being private method. Similarly, public variables or attributes and private attributes. We also saw how do we implement them. Really, there are no private and public keywords, but instead the convention decides whether it's a public or a private object. With this brief understanding on encapsulation in Python, let us wind up our current lecture, and up next we are going to have a look at another very interesting object-oriented programming concept in Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to extrapolate what we understood in encapsulation section. But again, this is not something related to the core encapsulation part of public and private attributes and methods, but this is something beyond it, where if we would want to modify a public object into a private object without any friction or without any additional work, how do we do that? Is there a way to do it? If yes, what is it? We are going to discuss that in detail in this session. Let us straight away jump into a Jupyter notebook to understand and implement them in detail. Let us create a new Jupyter notebook and rename it as Advanced Encapsulation in Python. Let's create a new class called Celsius, and what we will do in this case is we will first define a constructor. How do we define a constructor? We will have _init method, which will at first take self as one of the argument, and the second argument what we are going to define here is temperature, and we will assign a default value of 0 to it. Now inside this constructor we will have an instance attribute or instance variable termed as temperature, again created and assigned with the input argument temperature. And using this instance attribute, we will create another public method which is called as Fahrenheit conversion or to_Fahrenheit, which just means when we have the Celsius temperature provided, we need to convert it to Fahrenheit. So how do we do that? We have a mathematical expression which is going to do that. We will first pick up the instance attribute which is temperature, and we will multiply it by 1.8 times and add 32 to it. So this will help us in converting the value from Celsius to Fahrenheit. So now let's execute this cell. We now have a class called Celsius created in this program. We will now use this class to create a Celsius object. So now we will have room_temperature, which is an object created using the above defined class, which is Celsius. Now once we instantiate Celsius class, we will have an object created which comprises of an instance attribute called temperature. And the value of the instance attribute for now is 0. Let us try to modify the value of it. How can we do that? We can use roomTemp.temperature and assign it with a value of 23. Now the value 23 is in Celsius. Now we would want to convert this temperature from Celsius to Fahrenheit. How do we do that? We have a function called to_Fahrenheit to do it. If we just invoke the public method to_Fahrenheit from roomTemp object, it will pick up the instance attribute which is temperature and convert it from Celsius to Fahrenheit. Now we could see that the Fahrenheit value of the temperature, which is 23 degrees Celsius, is 73.4. Now let's further assume that our class got popular among the developers and clients and they started using it in their programs. They did all kinds of assignment to the object. And one fine day, there comes a specific requirement from the set of developers stating that temperatures cannot go below minus 273 degrees Celsius, which is also termed as absolute zero value. So they ask us to implement this value constraint. So make sure that never ever temperature can be set below minus 273 degrees Celsius. Being somebody who would like to develop whatever the developers and the clients want to, we happily heeded the suggestion and released a new version of the existing class. Let's see how our new version of class could look like. One of the obvious solutions to implement the required constraint is to hide the temperature attribute and implement the interfaces called as setters and getters to manipulate the temperature value. We shall now see how do we implement them. Let's redefine the Celsius class, and we are going to have a method called getTemperature, which is public in nature. Now this getTemperature will have one of the arguments as self, and inside this we will have the return value as self._temperature. Now if you remember right, if we would want to hide the temperature variable, all we need to do is make it as private. We can consider this public function as a getter. Similarly, how do we write a setter for it? We will write a setter which will have one of the arguments as self and the second argument being the input value which the user provisions. And we are going to check whether the value is less than minus 273 or not. If it's lesser than minus 273, then we are going to raise a value error exception stating temperature below minus 273 is not possible to be set. If not, if it's greater than minus 273, then we are going to modify the temperature value to the added one by the user. Now when we want to convert the temperature from Celsius to Fahrenheit, all we are going to do is we are going to define a function to convert it from Celsius to Fahrenheit, and to access the temperature we are going to use our getter function. That's great. Similarly, the constructor is modified as follows to set the value of the temperature via our setter method. So now let's execute this cell. We now have the Celsius class defined in our program. If we now try to instantiate this specific class with the temperature value lesser than 273, let's say I'll give 277 and assign it to room_temp, we are going to see a value error exception which is going to tell us this specific value below minus 273 is not possible. How did it happen? When we try to instantiate this class, we passed an argument with value minus 277, and we know that we have a constructor created here, and the constructor will be passed with this minus 277 value, and that constructor will call or invoke the set_temperature function which will have the value comparison and raise an exception which is provided below. Whereas any value that is higher than minus 273 will be taken care by our class, and that will be set as part of our class attribute temperature. Let's say I'm going to give it as 37, and now if we see what's the value of temperature by using getTemperature method, we will be able to see that the temperature in Celsius is 37 degree. This update successfully implemented the new restriction, and we are no longer allowed to set temperature below minus 273. But this is not of a great concern. The bigger problem with the above update is all the clients and developers who implemented our previous class in their program have to modify their code from object.temperature to object.get_temperature, and all the assignments like object.temperature equal to a specific value to be modified as object.set_temperature. This refactoring can cause headaches to the clients and developers with hundreds of thousands of lines of codes. All in all, our new update is not backward compatible. So this is where property feature or property object in Python comes to rescue. We will see how do we use property method or property object to make this successful without any kind of regression or code modification required by the developers and clients. So let's redesign or recreate the Celsius class, and will not modify to_Fahrenheit function nor the constructor. Then what we are going to do, we'll just keep both the functions the same way they were when the first version of Celsius was released, and we will introduce getter and setters as shown below. We now have a getter function as well as setter function. I've just also written the print statement to make sure how the flow goes, and we apparently realize where the flow is at a specific point of time in a program. After doing that, we are going to write that one rescue line of code which is going to help us bring in the getters and setters to our program without any code modification required by the developers and clients. What is that? Here we go. We are going to use property function or property method which is available as part of our Python code. Now if we see what is this built-in Python property object, it takes keyword arguments or arguments. We will have 3 or 4 arguments apparently which are present for this property object, where the first argument is a getter, second argument is a setter, and third argument is a deleter, and fourth is something related to document. By default, the values for them is none. So, and they are optional arguments. So what we are doing in this specific case is we are trying to use our getter and setter as the first 2 arguments. And what will this object gonna do? This property object attaches some code get_temperature as well as set_temperature to the member attribute temperature. So now any code that tries to retrieve the value of temperature will automatically call get_temperature instead of using the temperature access variable. Similarly, any code that tries to assign a value to temperature will automatically call set_temperature function. Isn't this a cool feature in Python? Yes. Using this feature in Python, we avoided a lot of modifications that are required by the end user to use the newer version of our class. We will now really see how it behaves. Let's use the Celsius class to create a room_temp object. And now it will have the class attribute which is nothing but temperature that's available in the specific code. Now we will use the same object to set the temperature value to 35 degrees. Yes, that works fine. If you see in both the cases, we have setting value printed here. The reason being, Celsius is a class which is having a constructor which is present here, which will write a statement self.temperature equal to temperature. So as I mentioned a couple of minutes back, whenever we try to set the temperature value, it implicitly invokes or call set_temperature function because of our property object. And hence we have the statement setting value printed here. Now again, when we try to explicitly set the temperature, obviously it's gonna call set_temperature because of the property object again, and thus we are seeing setting value presented here. Now I'll try to set the temperature value below -273, which is again -277. We get a value error stating temperature below -273 is not possible. So that's wonderful because end user doesn't need to modify anything in his code lines, but still he will be able to make use of this constraint check via our new class. If we go a little deeper into how the property object did that all for us, here it is. The property object by default has 3 methods in itself. Function for getters, function for setters, and function for deleters. So the one-liner code which we wrote in the previous instruction could be split into 3 lines of code as shown below, wherein we are going to create an empty property object and assign the getter function and assign a setter function to it. These 3 lines of code is equal to the one-liner that we wrote here. As we are familiar with decorators in Python, we can easily recognize that the above construct can be implemented via decorators as well. We can further go on and not define the names get_temperature and set_temperature as they are unnecessary and they may pollute the class namespace. For this, we will reuse the name temperature itself while defining our getter and setter functions via decorators. The same can be achieved with the help of decorators as shown below. We have a class Celsius where it has a constructor and Fahrenheit conversion function which is written, and we have this decorator called addProperty for which this temperature function would be passed, and also addTemperature.setter for which this specific temperature function would be passed. I will not be explaining how a decorator works now. If you want, please go back to our decorators session where we have detailed explanation of how decorators are going to work in case of functions. Let us execute the cell. We now have the Celsius class using decorators created, and we will instantiate it and assign it to an object called room temperature. Now we will try to assign value of temperature in this room temperature object to, let's say, 35 degree or 25 degree, we will be able to set the value. Similarly, we will be able to also retrieve the value from this object. Now, if we try to set the value of temperature in room temperature object below -277 or below -273, we will be able to see this value error. So with the help of decorators, we were able to achieve the same which we tried to achieve using property function explicitly. So in this session, we now had a thorough understanding of how property object in Python acts as a rescuer to not modify the end user code, but existing class can be modified to bring in the getters and setters without end user need to modify anything at his end. So that's great. We had a look at one of the very interesting and cool features in Python. So up next, we are going to have a look at few more interesting and fascinating concepts in object-oriented programming of Python. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a complete guide for beginners. In this session, I'm going to take you through one of the most used concepts in object-oriented programming, which is nothing but inheritance. Before I get into the details of what inheritance is, let me take you through one of the genealogy example. So what it is all about. Here is a grandfather who says he uses left hand to write and right hand to hold walking stick. Okay. And now here comes his son who just says, hey dad, even I do use my left hand to write, but he also mentions that he has 6 fingers in his hand. And now his dad replies back stating, you use left hand to write because you have inherited it from me. That's right. It is the right word that needs to be used here, which is called as inheritance. And such kind of inheritance is termed as simple inheritance, where one object inherits from another object directly. In case of inheritance, the objects that are considered are nothing but classes. So the base class or superclass is a class from which the characteristics are inherited. And the class that inherits from the base class is termed as subclass or a child class. After understanding what inheritance is, especially what simple inheritance is, let us move ahead and understand what are the different other varieties of inheritance that exists in object-oriented programming in Python. Let us consider another scenario where the grandfather says, I use my left hand to write and right hand to hold the walking stick. And now comes the son. He says, hey dad, I use my left hand to write because I inherited it from you. Additionally, he has 6 fingers in his hand. Here comes the grandchild. He says, I have 6 fingers in my hand, dad. Seems like I inherited it from you. And I also inherited the nature of writing in left hand from my grandfather. So we now have more than one level where people are talking about the characteristics they inherited from their parent and grandparent level. Considering all these 3 entities which are part of the scenario as classes, we can term this as multi-level inheritance, where the topmost class from which all the other classes inherits the feature is termed as base class or superclass, and the class which acts like a parent class as well as a child class in the multi-level inheritance tree is termed as intermediate subclass, and finally the leaf class is termed as derived class. So to reiterate again, root class is termed as superclass or base class. The class which acts like a parent as well as a child is termed as intermediate or subclass. And finally, the leaf class is termed as derived class. With these details about multi-level inheritance and simple inheritance, let us get into the next scenario and understand what is the other category of inheritance that's present in Python object-oriented programming. Here we go. Let us consider another scenario where we have a husband who says, hey wifey, I have 6 fingers in my hand. And then comes the wife and says, hey hubby, I have got brown hairs. And here comes their child who says, hey dad, even I have 6 fingers in my hand. Looks like I have inherited it from you. And he also responds back to his mom stating, hey mom, I do have brown hairs, which is most likely that I have inherited it from you. Again, considering all these 3 entities which are part of this scenario as classes in Python, we can easily term this structure as multiple inheritance, where one class inherits from one or more base classes. So in this example, we have more than one base class or superclass from which a child or derived class is created. So with this briefing on what inheritance is, what are the different categories of inheritance that exist in Python, let us quickly jump into a Jupyter notebook to implement each of them in detail. Let us create a new Jupyter notebook and rename it as Inheritance in Python. Once the Jupyter notebook is up and running, let's go ahead and implement a very simple example to demonstrate what simple inheritance is in object-oriented programming with Python. Let us create a new class whose name is person, and inside this person class we are going to define a constructor which is nothing but _init_, which will take two arguments, one being the self and the other being name of the person. Now inside this _init_ method, we are going to write an instruction self.name is equal to name. So now the left hand side argument name will become an instance attribute name, and the right hand side name will be the value that will be passed as an input argument to this function or the constructor. Now the next function that we are going to define is a getter function, which is nothing but get name, and it will take again one argument which is self, and this is going to return us self.name. Now we will define another function which is called as isEmployee. Now this will take again one of the arguments as self, and it is going to return false. Now instead of having the value to be returned as false, all we are going to do is we will have another input argument named as valid and set with a default value of false for person class will now be used for the return statement. On the same lines, we will also have another function which is termed as isManager, which will again take one of the arguments as self and the second argument named as valid set to false by default. Now inside this function again we are going to return input argument valid. Let us execute this cell. We now have person class created in our program. Let us now go ahead and create another class called employee, which is going to inherit all the attributes and methods from the person class. So which means we are going to follow a simple inheritance to create an inherited class. How do we do that? We are going to start with the keyword class followed by the name of subclass, and within the parenthesis we are going to use the class name from which the attributes and methods are to be inherited. So in this case we want to inherit the characteristics or attributes and methods from person class, and hence we are passing it as argument for our employee class. Now let's execute this cell, and before executing this cell, let's have a simple pass statement inside this class. Let us now go ahead and create employee1 using the employee class. Let's instantiate the employee class. We now see an error stating _init_ is missing one required positional argument name. But we have never defined init method or the constructor inside employee class. So where is this init coming from? Though the derived class do not comprise of any constructor, the class from which it is inherited or the base class has a constructor defined in itself. So whenever we try to instantiate a class, especially a subclass or a derived class, though we do not have constructor method in it, it looks for the constructor present in the base class. If there is a constructor in the base class, definitely that constructor will be invoked if the employee or the subclass do not have constructor of its own. So the flow goes this way. Whenever a subclass or the derived class is instantiated, it looks for the constructor or _init_ method in the subclass itself. And if the subclass or the derived class do not have any constructor defined in itself, then it will look for the constructor from the base class from which it is derived. Same has happened in this case as well. Because we do not have any constructor defined for employee class, it looks for the constructor from the person class. And we know that the constructor takes another additional argument which is called as name, but we did not pass any value for name. Let's pass the value for name as John and re-execute this instruction. We now have this cell executed successfully. Now the object that is created by instantiating the employee class will now have access to all the attributes and methods that are present in person class. For example, in this case we have employee_1, when we say dot, press tab, we would see the methods and attributes that this specific object can access. We could as well verify the same by using _dict_, which will say the instance attribute for this specific instance. We could see that name belongs to the instance employee_1 because employee_1 has access to all the attributes which are present in the class person. Now, if we would want to see what's the value of name, we could get it in two ways. We could just directly use name here to get its value. If not, we could use the method, which is nothing but getName, to find the value of name attribute. This is one of the very primitive cases of what and how a simple inheritance can be implemented in Python. Let us go ahead and modify the employee class. Let's take this employee class and modify it, where we are going to define its own constructor at first, _init_, and we will have self as one of the argument, and again name being another argument. Because we already have the assignment of name to the instance attribute name in the base class person, we just want to reuse it. How do we do that? We could do it very easily in two ways. We can either use the class, and inside this class we know we have this function called _init_, for which we can pass the argument name. This is one way in which we can do. Apart from this, we have another convenient and Pythonic way to do it by using the function called super in place of the class. So what is this super function going to do? I'm not going to explain in detail now what is this super function going to do, but I'm just going to give you a very quick gist of what it is all about. And in the coming lecture, we are going to have a detailed explanation of what super is going to do in multiple category of inheritances in object-oriented programming. In this case, super function will invoke the base class from which the current class is derived. So super function will play the role of the base class, which is nothing but person, and is going to invoke this _init_ method from the person class by passing this argument. This will let us creating an instance attribute name. Now for this employee class, inside the constructor we will consider another argument called employee ID, and now we will have self.employee_id equal to empid. So for an employee, we definitely need an employee ID, which will be passed as an input argument to the class, which will be taken up by the constructor to create another instance attribute called employee_id. Once we define the constructor, we will also define another method which is termed as isEmployee. Let's use the same code what we invoked or what we used in case of person class, and instead of passing valid equal to false, let's pass the value as true. And we will also define another function called getEmployeeID, which will take again self as an argument, and this will return self.employee_id. So let's execute this cell. We now have the employee class created in our program, and this employee class inherits several attributes and methods from person class. Let us now go ahead and create a new employee object, which is nothing but employee_2, and we are going to instantiate by using employee class. And we know that employee class has a constructor on its own which requires at least 2 arguments. We shall pass the same here. We will have James and employee number being 1, 2, 3, 4. Let's execute this cell. We now have employee_2 object which is created using employee class, and this also has some of the attributes and methods inherited from person class. To know more about it, we are going to use the built-in or the available dictionary, which is nothing but _dict_, which will give us the information about the instance attributes that are available for this specific instance. So if we see here, it has 2 instance attributes, one being employee_id, the other one being name. We know that employee_id comes from employee class, whereas name comes from person class. This is present here. This is one of the ways in which the simple inheritance can be achieved, where we are going to make use of the name attribute and some of the functions that are defined inside the base class person directly by the object that is instantiated using the derived class. For example, we could now directly ask for the name of employee_2 by using the name attribute directly, or we could even use a function called getName, which will help us getting the name attribute of the specific object. And we know that the name attribute comes from the person class, which is a base class. Similarly, getName function also comes from the base class. So this is how the object which is instantiated using the derived class can make use of the directly available functions and attributes from its base class. And this form of inheritance is termed as simple inheritance in Python. Let us proceed ahead and create another class termed as manager, which is going to inherit from employee class, which is defined above. Now, inside this class, we are going to define a constructor via double underscore init double underscore method, which will have self as the first argument and name as the second argument, following to which we will have employee ID and manager ID. Now we will have inside this constructor self dot manager underscore ID equal to manager ID, and we now have to define the name and employee ID. How do we do that? Because we are making use of employee class which is created above, and we know that employee class in turn makes use of person class which is defined above, we can clearly make use of both the classes to define name and employee ID for our manager. How do we do that? We will first invoke this super function, and we know that whenever we try to invoke the super function, it is going to use the employee class or the base class from which the current class is inherited. So the super will point to employee now, and employee class has a constructor which is underscore init, which will take name and the employee ID. And the underscore init or the constructor which is present inside the employee class internally calls the constructor from person class to define a name, and the constructor defined inside the employee class helps us defining the employee ID of the manager. Once the constructor is defined inside this manager class, we are going to define another method which is called as isManager, and we will have self as one of the argument, and we have another argument called valid which is set to true, and this is going to return as the valid argument. Now we will also have another function which is called as getManagerID. This will take self as the argument and returns as self dot manager underscore ID. Let's execute this cell. We now have the manager class created. Let's create an object called manager underscore one, which will be instantiated or created using manager class. And we now know that the manager class has its own constructor which will take three arguments. The first argument being name of the manager, let's say it is Williams, and the second argument being the employee ID of the manager, 10, and the third argument being manager ID of the manager, which is 100. Let's execute this cell. We now have manager underscore one object created. We will now see what are the instance attributes of this specific instance using underscore dict underscore. This will tell us what are the instance attributes that are present. We now have three instance attributes, one being employee ID, the other one being manager ID, and the final one being name. We know that only manager ID is defined inside manager class, but employee ID comes from its base class which is employee class, and the instance attribute name comes from its grandparent class which is nothing but person class. So in this case, it's not just a simple inheritance, instead it's a multi-level inheritance where employee is inheriting person and manager is inheriting employee. So we now have two different levels of classes which are inherited by manager class. And this is a very nice example of multi-level inheritance. It's not just the attributes, it's even the methods that are used by manager belongs to both the classes. For example, if I want to know the name of the manager, we can use the getName function which comes from the grandparent class person. Similarly, if we would want to know the employee ID of this manager, we can just use getEmployeeID function from the employee class. So with this, we are now able to not only use the attributes from above classes, but we are also able to make use of the methods or functions from the above two classes. And this is a very nice example, as I mentioned earlier, for multi-level inheritance in Python. With this, we had a thorough detail and understanding of what inheritance is all about and what are the different categories of inheritance that are there in Python. And we also saw how do we implement simple inheritance, along with which we also saw how do we implement multi-level inheritance in Python. Up next, we are going to have a look at what is multiple inheritance and how do we make use of multiple inheritance in Python. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to continue discussing about inheritance and object-oriented programming of Python. So what part of inheritance are we going to cover? We are going to cover multiple inheritance in Python, before which we will try to understand in detail about the keyword or function super in Python. We remember that we have used super function in our previous lectures during the invocation of the parent classes, but we will now understand it in detail via a Jupyter notebook. So wait for what? Let us quickly jump into a Jupyter notebook to understand and implement various concepts of inheritance in Python. Let us create a new Jupyter notebook and rename it as super and multiple inheritance in Python. Once the Jupyter notebook is up and running, let us consider a very simple example of a person class which comprises of a constructor and a getter function called as getName. Let's execute this cell. We now have the person class defined in our program. We shall now go ahead and create another class which is called as employee. How do we create it? It's the same way how we created the above class, by using a class keyword, and this employee class is going to inherit from the above person class. Inside this class, we will have again another constructor underscore init which will have self, and inside this constructor we are going to write a code stating super followed by underscore init method, and this underscore init method will need at least one positional argument. Let's pass it as John. Let's execute this cell. We now have the employee class inherited from person class, and hence when we try to use this super function, it invokes or it calls the class from which the employee class is inherited. So which means super here denotes person class. This is what we understood in our previous lecture. Let us completely understand in detail how exactly the super function behaves. Does it take any argument? If so, what are they? So let's try to understand all of them and have a clear picturization of what super function is all about. Now let me make a small modification to the above class. Let me create name, and I'll use this name as an argument to this underscore init function. Let's execute this cell. We now have the employee class available. I'll create the employee 1 and use the employee class to instantiate and create an object, and I'm going to pass one argument as John. Now I have employee 1 whose name is John. Let us now backtrack and see what did this super function do. To do that, let us first understand what is this super function all about. Let's try to now use this super function outside a class. Let's say I'm using this super function, and if I try to see its definition, it requires a class and it requires an object as the second argument. So I'm going to pass employee class as one of the arguments, or the first argument, and the second argument being the object. Why do we need to do so? So what is this super function going to denote when we are trying to pass these two arguments? It just says that find the super function of employee class, or find the base class from which the employee class is inherited, and apply a method on this object E1 of employee class. What method can be applied here? Before that, let me try to modify the employee class by creating one more method which will say get details, and this will have one argument as self, and it will have the print statement which will say name of the employee is, we will have self dot name. Let's execute this cell. We now have the employee class created. Let's create the E1 object, and we have E1 dot name. Coming back to this super function, if we now try to execute getDetails function which is present in employee class, we are going to see an error stating super object has no attribute called getDetails. That's because super object now denotes the base class of employee and not the employee class in itself. So which means we could only execute the methods that are available in the parent class of employee on even object when we are using super function. So instead of using getDetails, if we say getName, we will be able to easily execute it and see the result as John. Because this entire super function will now be denoting the specific class called person, which is a base class from which the employee class is inherited. In general, super function is going to pick up the super class or base class of the derived class that's mentioned as first argument and apply the method which is present in the base class on top of the object mentioned in the second argument. So it's always this way, where it picks up the super class of the class that's mentioned in the first argument and apply the operations present in that super class or the base class on top of the object that's mentioned in the second argument. To illustrate the same, let's create another employee object whose name is James, and we will name it as E2. Now once the E2 object is created, let us use the same super function and pass the first argument as employee class again, and the second argument this time is E2 and not E1. And on top of this, let's use getName function. This will return as James this time because getName function, which is present in the super class of employee, operates on E2 object. Now understanding how super function behaves externally to a class, let us now try to understand what exactly happens or how a super function behaves when it's used inside a class. Because inside a class or inside a constructor, we are not going to pass any argument to the super function. Then how does this super function behave? Let me take you through that. First of all, it requires definitely 2 arguments, but those 2 arguments are optional in nature. Then what are the default values that would be passed when it's used inside a class? The first argument definitely will be the class within which this super function is called. So it will be nothing but employee, and the second argument will be self. So any object that invokes this init function or the constructor will be used as the second argument. And the first argument will always be the class within which super function is invoked. So let's execute this cell, and we will now try to create an object called E1 using the employee class and have the first argument as Johnny, and let's execute this cell. We now have the employee object E1 created, and the behavior of the super function should remain the same, where it is going to pick up the base class or the super class of employee, which in this case is person, and it will try to invoke init method or the constructor of person class by passing the value of the argument as Johnny, and it will create an instance attribute for the object self or for the object E1. So if we now see the value of name in E1, it will be Johnny. So this instruction where we have passed super of employee comma self will be same if we don't pass any argument to it. So having no arguments passed will definitely take the class within which the super function is invoked as the first argument, and the second argument will be the self, which will be nothing but the object who invoked this constructor. With this, we had a detailed understanding of what super function is all about. How can we modify the behavior of a super function? Let us now proceed ahead to implement multiple inheritance in Python. Let us proceed ahead and create another class which is termed as product owner. So we will name it as product owner, who as well inherits from the person class. And now in the getDetails section, you will have name of the product owner is self.name. So the product owner class as well as the employee class inherits from the same person class. Let's execute this cell. We now have the product owner class available in our program. Now what we are going to do is we are going to create another class which is named as intern. And now I would want intern class to inherit from 2 classes. One class being employee, the other class being product owner. This is the way in which we can create a class which could inherit from one or more classes. So this way of inheriting a class from more than one class is termed as multiple inheritance. So whenever we would want to inherit a class from more than one class, we will be mentioning those class as part of the arguments with comma separation. In this case, we are trying to create intern class, which will be inheriting the attributes and methods from employee and product owner class. So the base classes for intern classes, employee as well as product owner. So we will not define anything inside this class. Instead, we will just have a pass statement. Let's execute this cell. We now have the intern class available in our program, which inherits from two classes, employee and product owner. Such kind of inheritance is termed as multiple inheritance, where one class inherits from more than one class. So the base classes for intern class will be two classes, which are nothing but employee and product owner. To track the flow of execution, let us create a init method or the constructor here, which will take self as one of the arguments. And inside this, we will have a simple print statement, which will say, I am inside intern class. Let's execute this cell. We now have the intern class available, which inherits from employee and product owner class. Let's create an object of intern class, which is nothing but intern underscore 1, which will be created using instantiation of intern class. Let's execute this cell. We now have intern underscore 1 object, which is of type intern class. Because of the constructor having the print statement, we see the print statement result here. We know that this object intern underscore 1 can access all the attributes and methods from both employee as well as product owner class. Now what we will do is, we will try to execute the method getDetails using this object intern underscore 1. What is the result that we are going to see? Before I execute the cell, let us go back and witness or see where the getDetails is coming from. GetDetails is a method that is defined both in product owner class as well as in the employee class. So whom does this getDetails refer to when I'm calling from intern underscore 1 object? We could see one similarity that exists in getDetails function of both the classes. That's nothing but accessing the attribute name from the object. But here in this case, for intern underscore 1 object, we don't have a name attribute yet defined. So what are we going to do first? We are going to first define intern underscore 1 with name attribute and assign it value as, let's say, John, and execute this cell. We now have intern underscore 1 with name attribute. Now let's execute this cell where we are going to invoke this getDetails function. We are going to see that it returns us a statement, name of employee is John. And we could see that this print statement comes from employee class and not from product owner class. So what is the reason for getDetails function to be invoked from employee class and not from product owner class? Let's have a look at it in detail. In case of object-oriented programming in Python, every class will have its own order of execution. So which means for a given derived class, there will be order of classes that is defined for its base classes. This will very much help when we are trying to execute any method from a derived class when it is having multiple inheritance. Let us understand that in detail, but for now to realize what is that order of classes, let's take up the class name. In this case, it's intern, and this class can be executed with a method called MRO. Let's execute this method and we will see that it is first intern and then employee and then product owner and then person, and finally there is a default class called object, which is always considered as a root class. And this MRO is nothing but method resolution order. Now we are going to consider this MRO and understand what this MRO is all about and how is this MRO created for every class. So with these details, let us wind up the current lecture, and up next we are going to have a detailed lookup and understanding of what method resolution order is all about and how is it used in multiple inheritance. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to continue what we exactly discussed in our previous section. If we remember right, we were discussing that classes in object-oriented programming of Python have something called as orders. So what do? These order of classes lets us know what is the method resolution order in case of inheritance in Python. And MRO is the function name that will let us know what is the order of the class given a class name. We are now going to go in depth of what MRO is and how is the MRO decided for a given class. Here is our problem during multiple inheritance. We have class A, which has method or the function called greet. We also have class B, which has the same method greet. And we now have class C, which inherits from both class A and class B, which we term it as multiple inheritance. Now let's say we create object C from class C. Then we try to invoke greet function from this object C. Would it invoke greet function from class A or class B? Way to figure out which one of the class will be used to invoke greet function is via method resolution order, which is also termed as MRO. Now what is this method resolution order? MRO or method resolution order defines the class search path used by Python to search for the right method to be used in case of classes having multiple inheritance. Yes. What is the underlying algorithm used by MRO? It's nothing but a C3 algorithm. So this algorithm is more of math and less of Python. Let us now understand what this C3 algorithm is all about. Now this C3 algorithm internally uses one of the mathematical operation called linearization. And this linearization is applied on top of classes to find the method resolution order. So interchangeably I'll be using the names linearization of a class and MRO of a class. Before we get into the algorithm details, let's learn some notations first. We have list of classes, head and tail, which are the few notations that we would be using in the algorithm. Let's say if we have C1, class C2, class C3 till class Cn, they are termed as list of classes. And now the first class in this list is termed as head. And the remaining set of classes are termed as tail. So in the list of classes, the first class will be termed as head and the remaining set of classes are together termed as tail. Another notation that we will be using in the algorithm is sum of list. Let's say we have class C, which needs to be added with list of classes C1 to Cn. We are going to denote it by having class C followed by list of classes C1 to Cn. So what this C3 method resolution order or linearization of a class is all about? It's nothing but list of ancestors of a class C, including the class itself ordered from the nearest ancestor to the furthest. And this is termed as class precedence list or linearization of class C, which we interchangeably term it as MRO or method resolution order of class C. How do we formally define it? Here we go. The linearization of class C is nothing but sum of class C plus the merge of linearization of its parents and the list of its parents. Kindly do not get lost with this definition. Let me try to represent this in mathematical format, which will be very easy to understand. Linearization of class C is nothing but class C in itself plus merge of two entities. One of the entity in the merge function will be nothing but linearization of its parent classes and the other entity in the merge function will be list of parent classes. Let me reiterate again. Linearization of class C is nothing but class C plus merge of two entities. The first entity in the merge function will be linearization of its parent classes and the second entity will be list of the parent classes. Now, what is this merge function all about? Following steps will detail about finding merge. Now to start with, we know that the merge function will have list of classes as its input arguments. Out of several lists available inside the merge function, pick up the first list and take the head of that first list. And now if this head is not in the tail of any of the other lists, meaning head class of the first list can only be present as head of the other lists as well. If not, they should not be even present in any other list. So in this case, where the head is not part of any of the tail of the other list, then add it to the linearization of C and remove all the occurrence of that specific class from the list in the merge function. Now as a next step, We have to otherwise look at the head of the next list. If the head of the first list does not obey the second point, then we have to look for the head of the next list and take it if it's a good head. What do we mean by a good head? If it follows the second point and obeys the second point which we have mentioned above, which is nothing but the head should not be part of tail of any other list, then it's considered as a good head. Keep repeating the operations that we have mentioned in last 3 steps until all the classes are removed, or we reach a stage where it is impossible to find any more good heads. To visualize the merge definition and C3 algorithm, let's go through an example. We have object O in Python, which will always be considered or present as a default base class for any user-defined class. And we have class F, class E, and class D, which makes use of the same default object as the base class. And now we have class C, B, and A, which undergo multiple inheritance, wherein class C is using class D and class F as its base class. Similarly, class B is using class D and E as its base class. And finally, class A is using B and C as its base class. We have 3 classes in this example, which makes use of multiple inheritance in Python. Let's proceed ahead and try to visualize the above presented example. We now have the object O, where class D, E, and F use it as the base class for inheritance. And now we have class C, which is going to make use of class D and F as its base object. Similarly, we have class B, which is going to make use of class D and E as its base object for inheritance. And finally, class A is going to make use of class B and C as its base object. We now have clear visualization of the structure of the given problem. We are going to make use of method resolution order to find the order of classes. In this given example, using method resolution order or linearization approach, let us find out what is the linearization or MRO of class A. To start with, we are going to see what is the linearization of object O or class O. We know that the linearization of class O is O in itself because it does not have any parents. Now, what is the linearization of class D? Linearization of the class D will be class D in itself followed by its parent O. So linearization of class D is class list DO. Similarly, what is the linearization of class E? It's nothing but class E in itself along with class O. So linearization of class E is list of 2 classes E and O. Now what's the linearization of class F? It's nothing but list of classes F and O. That's great. These are the few simple linearization approaches because we don't have any multiple inheritance available here. We now have found the linearization of the ancestor classes O, D, E, and F. Let's keep them all aside. Now let's start finding what is the linearization of class B. Linearization of class B will be nothing but class B in itself plus merge of linearization of class D and E because they are the parents. So the first argument of the merge function will be nothing but linearization of its parents, and the second argument being list of the parent classes in itself. So linearization of class B is equal to class B plus merge of linearization of class D and E with list of classes D and E. Now what happens in the next step? We know that linearization of class D is DO and linearization of class E is EO, and we have list DE. We found the linearization of class D and E in our previous step, which we are going to reuse here. Let us go ahead and evaluate the merge function. With recollecting the steps that we mentioned for finding a merge, let's go ahead and find its evaluated value. To start with, pick up the head of the first list out of the lists available in the merge function. So the first list is DO. Pick up the head of that list, which is D, and verify whether it is present as part of the tail of the remaining list. We don't see D being part of tail of any of the remaining lists. So we can pull out D and make it available as part of the linearization of class B, which is nothing but linearization of class B is equal to B plus D plus merge of O, EO, E. Why did we remove D from last list as well? Because if the head is not part of any of the tail in the given list, then we have to remove all the occurrences of that head and place it as part of the linearization of that given class. Let's again evaluate the new merge function or the merge function with new list. To start with, we have the head of the first list being O, and we see that O is part of tail of the next list. So we are going to keep that as is without removing it, and we will pass to the next list EO and pick up the head of that second list, which is nothing but E, and verify is it part of the tail of any of the remaining list. And we see that E is not part of tail of any of the remaining list. In the last list as well, it's not a tail, instead it's a head. So there is no tail even in the last list. And hence we are going to remove that class E and place it as part of the linearization of class B. So new linearization of class B is B plus class D plus class E and a final merge function between class O and class O. And we know that the merge of O and O is O itself. So the linearization of class B is nothing but B plus class D plus class E plus class O. We know that summation of classes can be represented as follows. So finally we have figured out what is the linearization of class B, which is equal to B followed by class D followed by class E and then class O. We have now figured out the linearization of one of the other ancestral class called B. So let's place that aside. And now we will go to another ancestral class called C and find what is the linearization of class C. Linearization of class C is nothing but C in itself plus merge of linearization of its parents and list of its parents. And we know that class D and F are the parents of class C. So we have merge of linearization of class D followed by linearization of class F and the list class D and F. Now let's try to find the merge value of class D and class F's linearization along with the list D and F. We know that linearization of D is DO and linearization of F is FO, and we have the final list DF. So let's evaluate this merge function. To start with, we are going to pick up the head of the first list among the several lists present in the merge function, which here in this case is class D. And we see that class D is not part of tail of any of the remaining list. So we can remove class D and add it with class C as part of the linearization of class C. This is how our new expression looks like, where we have C plus class D plus merge of class O followed by list FO and the class F. Let us again evaluate the merge function with new list. So the merge function has the head of the first list being O now, and we could clearly see that O is part of tail of the next list. So we are not going to do anything to this class O and keep it as is, and we are going to skip or move to the next list, which is FO. And we see that head of this list F is not part of tail of any of the list. So we are going to remove this class F and place it as part of the linearization of class C. So the new expression will be class C plus class D plus class F, and finally we have merge of two same classes. So the merge of two same classes will be the class in itself. So the last expression would be C followed by class D followed by class F followed by class O. So the linearization of class C or MRO of class C is nothing but class C followed by class D followed by class F followed by class O. Let us now place the linearization of another ancestral class C aside. And finally, let us come to the linearization of class A. Linearization of class A is nothing but class A plus merge of linearization of its parents, which in this case is class B and class C, and list of class B and C. So the merge expression will be having linearization of class B, linearization of class C, and the list BC. Now what is the merge value? We know that linearization of class B is BDEO, linearization of class C is CDFO, and list BC. Let's evaluate this merge function. To start with, we are going to pick up the head of the first list BDEO and verify if it's part of tail of any of the remaining list. And we could clearly see that B is not part of tail of any of the remaining list, and hence we are going to remove the class B and add it with class A, and we have the new list as part of our merge function. We are going to redo the same by picking up the head of the first list, which in this case is class D, and verify if it's part of tail of any of the remaining list. We could clearly see that class D is part of tail of the next immediate list, and hence we are not going to remove it and keep it as is and move to the second list, which is nothing but CDFO, and pick up the head of this list, which is C, and verify is C part of tail of any of the remaining list. And we could clearly see C is not part of tail of any of the remaining list. So we will remove this class C and add it up with class A and class B. Now we have the new expression class A plus class B plus class C, and the merge expression will be modified to merge of DEO comma DFO. Now again we will redo it by picking up the head of the first list, which is D, and verify if this is part of any of the tail of the remaining list. And we could see that D is not part of tail of any of the remaining list. So we will have class A plus class B plus class C, and the class D will also be removed now. And the new merge function will have two lists, one being EO and the other one being FO. We could clearly see that head of the first list, which is E, is not part of tail of any of the remaining list. And the only remaining list is FO, and E is not part of it, and hence we are going to remove class E and place it as part of the linearization expression of class A. So our new linearization expression is class A plus B plus C plus D plus E, and the final merge expression is class O and class FO. And this merge expression clearly indicates that head of the first list, which is O, is part of tail of the next list, which is nothing but FO. So we are going to keep O as is and remove class F. So the order will be class A plus B plus C plus D plus E plus F, and finally the merge expression between the two same classes O. And the final expression of linearization of class A will be A, B, C, D, E, F, and O. So this expression of linearization of class A will denote the order or method resolution order for class A. So what does it mean in terms of object-oriented programming in Python? Let's say we have an object from class A which is going to call a function which is present in both the classes B and C. Then if we call that function from the object instantiated by a class A, it is first going to pick up the class B's function and execute, and not class C's function and execute. So the order in which the function will be executed or method will be executed will be based on this expression. Let's get back to our classic example where we have class A and class B. Both of them have methods with same name greet. And now we are going to create class C, which is going to inherit from both class A and class B, which is a classic example of multiple inheritance again. When the object created out of this class C invokes the greet function, which of the above two classes will be invoked? To know that, let us find the MRO or linearization of class C. Before that, let us visualize the above provided example where we have class A and class B, and we have class C which is going to inherit both of these classes. Now, what is the linearization of class A? It is going to be class A in itself because there are no more ancestors for class A. Similarly, for class B as well, linearization of class B is class B in itself. Whereas in case of class C, linearization of class C is class C plus merge of linearization of its parent classes and the list of parent classes. As A and B are the parents of class C, it will be nothing but linearization of class A and B along with list class AB. Now let's try to evaluate this merge function, and linearization of A is A, linearization of B is B, and we finally have the list AB as the last argument. So during the merge evaluation, as a first step, we are going to pick up the head of the first list, which in this case is A, and we are going to see is it part of tail of any of the remaining list. As it's not part of tail of any of the remaining list, we are going to remove the class A and place it as part of the linearization of class C. So the next expression is class C plus class A plus merge of two same classes, which is B in this case. So the next expression is class C plus class A plus class B. So the linearization of class C will be nothing but class C followed by class A followed by class B. And this is also called method resolution order. So what will happen for the expression object underscore C dot greet? It is going to pick up the greet function from class A and execute it. So we will see the result as hi, I am Mr. A, which is a print statement coming from greet function of class A. Taking up the same example in a Jupyter notebook and trying to create the object which is object C using class C, we will try to invoke greet function from the above created object. We will clearly see that it prints the statement hi, I am Mr. A, as the greet function is invoked from class A. How did it happen? It's because of the MRO or method resolution order. How do we find the method resolution order? Use this class C and invoke or execute this function called MRO. It will provide the order of class or linearization of class C. It's nothing but class C followed by class A and then class B. That's the reason greet function got executed from class A instead of class B. Let us now modify the above class definitions where we are trying to create a constructor in each of them, the underscore init self, and inside this constructor I am going to print a statement hi, I am inside constructor of class A. Similarly, let us define the constructor for class B as well. And for class B, we will change the print statement from hey, I am inside the constructor of class B. Let's execute this cell. We now have two classes A and B which has constructor and function called greet, and we now also have class C which is going to inherit from both of the classes. Now let's try to create a new object using class C. What is going to happen? Whenever we try to instantiate a class, it always executes the constructor. But we know that there is no constructor for class C defined. So what's going to happen? It must invoke or execute the constructor of its parent class or base class. Let's execute this cell. We clearly see that hi, I am inside constructor of class A is printed. That's because instead of executing the constructor of class B, it executed the constructor of class A. Why did it happen so? It's because again of the MRO or order which is used for method resolution. Constructor is also one of the method which follows MRO, and that's the reason whenever we do not have constructor defined in the derived class, it will pick up the method resolution order to figure out which constructor from the defined set of base classes to be executed. Not just this, let us try to modify again the above set of classes. Now what I'll do is I'll define a constructor inside this class C as well, which will have definitely self as one of the argument. And now instead of pass, we are going to use this function called super. And this super function is going to invoke init function, and let's execute this cell. We now have class A, class B without any modification, whereas we have class C which has a new constructor defined, and inside the constructor we have the super function calling init. Let's try to instantiate class C and assign it to a variable called new class, which will become the new object of class C. If we now execute this cell, it will say that hi, I am inside the constructor of class A. This is purely because super function pointed to class A in this case instead of class B. That's again purely because of MRO. Now, if at all we intentionally want init of class B to be called, how do we do that? How do we get it done? That's very much possible by modifying superclass. What do we need to modify here? We need to modify two arguments. One being the class which needs to be passed as the first argument, and the second being self. So the self always points to the object who calls or who invokes the init or constructor. Why are we modifying the first argument, which is class? By default, what will happen is super function will point to the next immediate class in the MRO. But we need to change that, or we need to bypass that. To bypass it, what will we do is we are going to pass A as a class to it. We know the MRO of this class C is C followed by A followed by B. So what we are going to do is, to the super function, I'm going to pass class A. So the super function of class A will return the super class of class A, which is nothing but class B. And this object will use the function underscore init from class B. So let's execute this cell. And now we will have new class object. And let's execute this cell. We will now see that, hi, I'm in the constructor of class B. So the entire control of what needs to be executed from super class is very much available to us. This session turned out to be a very long one, so let's have a quick recap of what we discussed in this session. We started by understanding there is an algorithm, there is a methodology which is followed to figure out which class should be executed first when we are having multiple inheritance. And that's called as method resolution order. And this method resolution order makes use of one of the mathematical concept called linearization, which is implemented via an algorithm called C3. We understood how C3 algorithm works and how is linearization achieved. Once that's done, we took several examples to reiterate through C3 algorithm and linearization technique to evaluate the expressions and figure out what MRO for a given class is all about. And we also saw MRO function, which is going to yield us the resolution order. With these details, let us wind up our current lecture. And up next, I'm going to take you through much more interesting concepts in object-oriented programming of Python. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through one of the very interesting and useful concepts in Python termed as polymorphism. And what this polymorphism is. Before we get into the details of object-oriented programming, let me try to explain you in general what polymorphism is. Let's take the example of this animal. This animal will morph to this color when it's on grass, whereas it morphs itself into this state when it's on cement block. When it is on a red soil, it gets morphed into this specific state. So the same animal, when it's on different environment, it morphs its state accordingly. In general, when same object is taking many forms, it is termed as polymorphism. So what it is in case of object-oriented programming? We have two variations in polymorphism. The first one being overriding. So what is this overriding all about? Let's take a very simple example, again about genealogy, where we have a father class and a son class. So what is this father class going to be comprising of? It has a method or function called hobbies, where father says walking and reading newspaper are his hobby. Now the class son, which is inherited from the class father, also has this method called hobbies. Now what happens in this case is, the hobbies defined in the son class overrides the hobbies which is defined in the father class. So any object that is created using son class tries to invoke hobbies method, it will definitely be using the hobbies method defined in the son class instead of hobbies method defined in the father class. And this concept is termed as overriding. We now have another very interesting concept called overloading in polymorphism. What this overloading is all about? Typically, there is no concept of overloading in Python. For example, let's say we have class father, which already has one function called hobbies, which takes 2 arguments. Now, if we try to create one more function named as hobbies with 3 arguments and try to create an object out of it and try to pass hobbies function from that object with 2 arguments, we are going to see an error stating it is missing one required positional argument. Why do we see it this way? It's purely because Python is having dynamic typing behavior, which means the latest object which is created with the name will be persisted and the older one will be removed out of the memory. But technically we could still achieve whatever we could have done with the help of overloading. How is it possible? It's possible with the capability of unpacking arguments which will very much match the behavior of overloading. What is this unpacking? We had the detailed discussion of unpacking in Python in our previous lectures. So let me give you a simple example of it. We have the same class father and we have hobbies function inside that. And the arguments that are passed inside this hobbies function will not be just static values. Instead, they will be arguments or keyword arguments. So that number of arguments that will be passed to this function can be dynamic in nature. Thus, with the help of unpacking the arguments, we are able to match the behavior of overloading in Python. So to brief it up, polymorphism is present in object-oriented programming of Python. It will definitely take two forms here as well, one being overriding and the other one being overloading. There is no typical concept of overloading very similar to other programming languages. Instead, the capability or the behavior what we could have achieved with the help of overloading is achievable with the help of unpacking arguments in Python. So with this, let us wind up our current lecture on polymorphism in Python. And up next, I'm going to take you through another very interesting concept in Python. Till then, take care of yourself. Have a great time. See you in the next lecture. Hello one and all. Welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I'm going to take you through one of the tiny concepts in Python, which is called as garbage collection. Yes, there is something called as garbage collection in Python. It's a process or an operation that is going to collect the garbage that's present in Python. What do we mean by garbage? Typically, any unused object in Python would be considered as garbage. So in the programming world, garbage collection is nothing but freeing up the memory by removing unused objects that is present in the program. So for example, let's say I have user class and there are three objects that are instantiated or that are created using user class. So we now have user class used in three different places. So Python will internally maintain in memory the count of usage of user class. At this point in time, the count of usage of user class is 3. Let's say now we are going to make the assignment of user1, user2 and user3 to none. What happens to user class count? There are no objects that are created using user class, which means the count of usage of user class is 0. And that's when garbage collector comes into the picture and automatically throws user1, user2 and user3 to a dustbin. So the process of memory management in Python is pretty straightforward, where it handles its object by keeping count to the reference of each object, which means each object stores how many times it is referenced in the program. This count is updated with the program runtime, and when it reaches 0, this means it's not reachable from the program anymore. Hence, the memory of this object can be reclaimed or freed up by the interpreter. Let's create a new Jupyter notebook and rename it as GC in Python. Let's create a class named as user, which will have a function called _del_, and this will take one of the arguments, which is self. Like how we have _in and _ as the constructor, we also have an operator called _del_ for destructor in Python. Now inside this function, let's have a simple print statement saying no references left for this specific object. We will use format function to write it. Let's execute this cell. We now have a class named user created along with a delete operator or _del_ operator, which acts like a destructor for this class. Let us now instantiate the user class to create user1 object. Similarly, let us create user2 using user class, and finally user3 using user2. Let's execute this cell. Now we have three different objects that are created. If we now try to assign user1 to none, we will immediately see the response of the print statement. That's because there is only one object, user1, that's been used. So the count of user1 variable or user1 object was 1, and once that was assigned to none, then we had to execute del operator or destructor so that we saw this print statement. Now we have user2 created with user class, and we also have this user2 used by user3. So what we will do now is we will execute this statement called user2 equal to none. Do we see the destructor execution here? Definitely no, because it's not that user2 is just instantiated using user class, but it's also used by user3. So until and unless user3 is assigned to none, we will not see the destructor getting invoked for user2 object. With this, we now know what is the operator that is going to be used as destructor in Python object-oriented programming. Let us now wind up our current lecture, and up next I am going to take you through one of the very interesting project which is going to make use of all the object-oriented programming techniques that we learned till now. So till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, I am going to take you through a project which makes use of all the capabilities in object-oriented programming of Python that we have learned till now. So what is this project all about? This project is all about television. So creating a class for television and creating multiple variants of television using object-oriented programming. So wait for what? Let us quickly jump into a Jupyter notebook to create the project on television using object-oriented programming with Python. Let us create a new Jupyter notebook and rename it as television project. We are going to start by creating a new class whose name will be television, and this class will definitely have a constructor. How are we going to define a constructor? We are going to define a constructor by using _init_name, and the first argument will be self along with width, height, screen size, max volume and current volume, and finally power state of television. In this case, width, height, screen size, max volume, current volume and power will be defining the attributes of television. So we are now going to assign some default value for max volume, which will be 100, and current volume it will be 0 because current volume can never go below 0. We will as well assign the default value for this power argument, which will be by default false, which means the television is in the off state by default. Now what we are going to do inside this constructor? We are going to define attributes or characteristics of television inside this constructor. So what kind of attributes are we going to define? It will be nothing but instance attributes. So how are we going to define an instance attribute? We will use this keyword called self. Along with this self, we will be assigning the attributes or characteristics for this television. How do we do that? We have self, along with which we will have the characteristics set. Self.width equal to width, self.height equal to height, self.screen size equal to screen size, and self.max volume will be equal to max volume. Similarly, self.volume will be equal to volume, and finally self.power equal to power. What did we do just now? We created certain set of characteristics for television object. So whatever is there on the left hand side will denote attribute or characteristic of television object. It could be width, it could be self.height, it could be self.screen size. Each of these will be defining instance attributes of television object. And whatever is in the right hand side is nothing but the argument that's been passed to this constructor. So whatever is there on the right hand side, width, height, screen size are all nothing but the input arguments that's been provided to this specific constructor. Once the constructor is defined, let us go ahead and define other methods. The next method that we are going to define is nothing but channel tuning. So what is this channel tuning all about? It is going to take one of the arguments as self, and the second argument will be channel number. Given the channel number by the end user, we are going to switch to that specific channel in this TV object. So how are we going to do that? For this, we are going to create a switch-like statement. We know that in Python, we don't have explicitly something called a switch, but we are going to use dictionary to do the same operation. So let me define a new dictionary named as switch, and this will have certain set of key value pairs. What are those key value pairs? It's going to be 3 key value pairs. The first key being 1 and its value is 34.56. So channel number 1 will have frequency or tuning value of 34.56, and the second one being 2, which means channel number 2 will have the frequency or tuning value of 54.92, and finally the third key with channel number 3 will have the tuning frequency of 73.89. Now after we have defined this dictionary, we are going to return specific value from this dictionary. How are we going to do that? We are going to use this switch and have this function called get, which will take the first argument as channel number. Based on the channel number, it is going to return the value for the end user, or it is going to tune the television for that specific channel. Now if in case end user sends a wrong channel, or if he sends a channel value which is not part of the switch, then what should happen? Then we are going to return the value as 0. We shall proceed ahead and create another function which we term it as power switch. This function is going to take self as one of the argument, and we are just going to toggle the current state of power of television. How do we do that? We use self.power, and we will use a not operator which will toggle the current state of power. Let's say if it's false, it will toggle it to true. If it's true, it will toggle it to false. Once this is done, let us go ahead and create another function, and we will name this function as increase volume. What is this function going to do? This will just have one argument self, and inside this function all we are going to do is we are going to increase the current volume of television. But before that, we are going to check if the max volume is greater than current volume. If so, then we are going to increase the current volume by 1. Similarly, we are going to create another function called decrease volume. What we are going to do in this function is, as the name suggests, we are going to decrease the volume or the current volume of television. How are we going to do that? We are again going to check if 0 is lesser than current volume. So if the value of current volume is greater than 0, then we are going to decrease the current volume by 1. Inside both increase volume and decrease volume function, let us print the current volume value of the television. Current volume value of television is, let us convert the integer value to string by using string function, which will be taking self.value as the input argument. Now again we will add the same print statement in decrease volume function as well. Let us now proceed ahead and execute this cell. We now have television class defined with a constructor, with a function or method to tune the channel, with a method to turn on or turn off the power, with a method to increase volume, with a method to decrease volume. Let's now create the first object of this television class, which we will name it as new television. This is going to instantiate television class by passing certain arguments to it, where the first value will be nothing but width, second value will be nothing but height, and the third value will be nothing but screen size. How do we know that? This is purely because the values that we are passing will be sitting in the arguments of constructor, which are nothing but width, height, and screen size. And we know that the rest of the 3 arguments have default value for which we are not going to pass any new value dynamically. So let's now execute this cell. We now have the constructor class invoked, and we have all the attributes set for this specific object called new television. Let's say now we want to see the width of this television. We will be able to find it. Similarly, the height and screen size. Now as a small modification to the existing class, let us go back and try to modify this power switch method. Let us check what's the value of power. If it's turned on, then what we are going to do is we are going to write a print statement stating television is turned on. If not, then we are going to say television is turned off. Now let's execute this cell. We now have the new definition or new method definition for power switch inside television class. Let us re-instantiate this object. Now what we are going to do is we are going to use the television object and invoke this method called power switch. Now it will say that television is turned on. That's purely because the current state of power is on in case of this television object. Now again, if I try to say power switch on this object, it will say the television is turned off. That's because power value of the television object is false. Now on the same television object, let us change the television channel. How do we do that? We have this function called channel tuning, to which we can pass one of the arguments as the channel number. Let's say I'm going to pass the channel number as 2. Then I'm going to see that the return value or the frequency to which the television is set is 54.92. Let us now modify the volume of the television. How do we do that? We will use the same new television object and invoke the function called increase volume. So this is going to check some condition and then increase the current volume of television. And now the current volume of television is 1. Similarly, if we would want to decrease the current volume of television, then we could use the function called decrease volume so that it will decrease the current volume of television by 1 unit. Having played a bit around the above created class and object, let us now go ahead and create another class which we term it as DVD player television. Now this class is going to inherit from our class television. So television will act like a base class for this derived class DVD player television. Now we will not define any constructor for this class because it will be using the constructor of our above defined television class. And now what are we going to define here? We are going to define a function called play DVD, which will take one of the arguments as self. And inside this function, we are going to write a print statement stating playing DVD on television with, we will concatenate it to a string value of self.width. So we will mention playing DVD on television with this much width and height equal to self.height, and this will again be passed inside the string, and also we will mention having screen size as string of self.screen size. That's great. Now we have a class called DVD player television, which is going to inherit from our base class television, and this DVD player television class has a method which is going to print playing DVD on television with certain set of attributes or characteristics. Now where are these characteristics going to come from? This is going to come from our base class television, because we have not defined any of these instance attributes as part of the specific object DVD player television. Instead, it is picked up from the class television. So let's execute this cell. We now have the new derived class DVD player television available as part of this program. This inherits from our class called television. Having said that, let us create a new instance of the newly created derived class. Here we go. We have a new object called DVD player television, which is created as part of the instantiation of DVD player television. Now why are we passing these arguments? This is because DVD player television, when it's instantiated, it is going to call or invoke the constructor of television class. And we know that constructor of television class takes certain set of arguments. So these values that we are passing as part of the argument list of DVD player television class will be going to the arguments of constructor of television class. Let's execute this cell. We now have DVD player television object available. Now what we will do is we will try to toggle the power state of this television. Now we will see that television is turned on. Now what we will do is we are going to execute play DVD method, which is specific to DVD player television. And it is going to say that I am playing DVD on television with 10.5 width and height equal to 7 units, having screen size as 9. Maybe I'll add some space here. Let's re-execute it. And we will see that playing DVD on television with 10.5 width unit and height equal to 7 units, having screen size as 9 units. Now again, these width, height and screen size are not the objects that are native to DVD player television class. Instead, it's been borrowed from its base class or parent class television. So we now had the base television class created at first, having certain set of characteristics or attributes like width, height, screen size, so on and so forth. And we have some methods to operate on top of those artifacts or on top of those characteristics and attributes. Some of those methods are involved in tuning the channel, some of them to turn the power on and off, some to increase the volume, some to decrease the volume. And we also instantiated that class to get the object out of it. And we try to juggle around some of the attributes and methods that this class provisions us. And then we try to create another class using the already defined class via our inheritance concept. And now we used some of the attributes and characteristics defined in the base class inside this derived class. We were able to successfully use them without any problem. With this project, we got our hands dirty on some of the key capabilities in object-oriented programming. Let us now wind up our current lecture, and up next I am going to talk about the gist of different concepts that we learned in object-oriented programming with Python. Till then, take care of yourself, have a great time, see you in the next lecture. Hello one and all, welcome back to Under the Hood of Python, a guide for complete beginners. In this session, we are going to have a recap of different concepts that we understood in object-oriented programming with Python. To start with, in object-oriented programming, we started understanding what are classes. Classes are the base for everything in object-oriented programming. So class is nothing but an idea, metadata or schema of something to be constructed. And what's an object? Object is the real existence of a class. So class is an idea and object is the real implementation of that idea. What are attributes? They define the characteristic of a class. There are two kinds of attributes, one being class attribute and the other being instance attributes. We have clearly understood the differences between the two along with their utilities. We have methods which define the behavior of the attribute. That means we can use the attributes inside the method, write a logic and set the value, get the value, so on and so forth. So methods are nothing but functions inside the class to define the behavior of the class. And we also have one of the very important concept called constructors. We understood constructors are the special variants of methods. These constructors are methods that will be invoked implicitly when an object is created or implicitly when a class is instantiated. And constructors are defined with the special name _init _. And we also have something very important which is called as self. This plays a very crucial role in any method in class of a Python. All the methods have their first argument as this self operator. Self will always denote the object who invokes the method and operates on top of that object. We have encapsulation. This is purely to deal with the privacy of attributes and methods. Here comes the property object. This will help to encapsulate the existing attributes and methods in a much easier way. And the most important concept, which is inheritance. Inheritance helps us to reuse the already existing class, define the hierarchy of classes so that each of them are connected in a right sense. Super is a function that helps derived class to call its ancestor classes. Now, what is the order in which it should call? Who will decide it? That is decided by MRO or method resolution order. And we know that this method resolution order uses one of the algorithm called C3 algorithm, which implements linearization technique of mathematics. And here comes polymorphism that helps to override and overload the objects which are present in Python. And finally, garbage collection to clean up the unused objects. That's great. We understood a lot of concepts in object-oriented programming and also got to know the various behaviors and behaviors in various circumstances of each of them. So having the gist of various concepts in object-oriented programming, let us wind up this lecture and see you back in the next session. Till then, take care of yourself and have a great time.